Hey chat, how's it doing? Oh no, good start. How's it going, chat? Welcome to today's stream. It is a very special stream. We are joined once again by Dave. Before I say hello to Dave, let me quickly do some hellos for those in chat. Who do we have with us today? I see Gumby Time 2008, Red, Box, Randy Lee, FUZE Arena, who's that? Kerr, had to make a channel. Note on Guy, Chaz Cozy, Pizza Here, Manguy 12, Terranova, Voxy, Mr. O, Professional right from the start, Classic Dom. That's me, Mr. O. Steve's Gaming, welcome. Thank you all for joining me here today on this fine Sunday. Hey, Bari. It is always a treat to have Dave with us, but I'm doubly excited because we're going to get started on a little something special, I think, today. Dave, are you there?
I am here, hopefully.
Hey, Dave. How you doing?
I'm all right, yeah, thank you very much. I'm all right. It's been a very sort of relaxed Sunday, I must say. It's gone very quickly. Not much light these days.
Yeah.
Sort of, you wake up, you do a bit of painting on some Warhammer miniatures, and then it's dark all of a sudden.
Yep, it is. Yeah. By the time you've actually woken up, because there's a different thing between getting up out of bed and actually waking up. It is.
Oh, that's very true.
It's already halfway through the day.
That is so true. I don't really count myself as awake until I've eaten. At least I feel like my brain just doesn't react properly until bacon has entered the body.
I'd just like to say
it's really good to be here again, Dom. It's really good to be here. I'm very excited.
Me too, Dave.
Long time no. We've been chatting a bit behind the scenes, but it's really good to be back with your chat as well. And hi to everybody in the VideoDojo community. As usual, good to see you all.
It is wonderful to have you as always, Dave. And yeah, it's been a little long between our last one and this one, so I'm so keen to get back into it. Just very quickly want to say a big thank you to Nintendo Plush for becoming a VideoDojo premium channel member. Thank you very much for your support. Everybody, could we have a nice warm welcome for Dave? And I'm going to bring the music down so we can switch over to the Switch. All right. Okay. Oh, had a little preview of Dave's window there. Dave, what's our plan today?
Okay. Well,
where shall we get started?
Okay, well, we'll have a little chat about the plan, and then we'll sort of decide on the best place to get started. I have an idea of where I'd like to get started, and it's going to put you on the spot a little bit.
Ooh, okay.
I think. Don't worry, I'm not going to give you any testing. It's going to test a different sort of ability than we usually do on this. But so far, just to keep everybody up to date, and I trust that pretty much everybody here probably has seen the previous streams by now. But just in case they didn't, this is sort of the third part in this series, isn't it? And we've covered our basic concepts. We've gone over those basic fundamental coding concepts that are really going to get you off the ground in the FUZE⁴ application. Not just in FUZE⁴, but also in any coding environment, right?
Yeah.
These are core coding concepts that transfer to all different coding environments. But if you're looking to create a game in FUZE⁴ and you're coming from something like Game Builder Garage, you're going to need a bit of a grasp on these concepts a bit more formally. And so that's all sort of, I'd consider that out of the way, although we will be revisiting them again and again and using them in situ, sort of in context, because we could really provide endless examples of these concepts being used. But of course, then we'd never really put it into practice. So the whole idea was to create more like a practical game sort of project, a larger scale project, because that's what really everyone is aiming for when they pick up something like GBG or something like FUZE⁴, I think.
Yes.
And we tell people again and again, and I will continue. I'll die on this hill. This is the gospel truth. You should set your sights low when you pick up an application like this. If you get GBG or you get FUZE, and you're thinking, right, I'm going to make an entire game that's as big as Pokemon, and I'm going to have this, and this. You might do it, and if you do, then power to you. And obviously, if you are at that level already, then great. But if you're inexperienced and it's your first time doing this sort of thing, you want to set your sights nice and comfortably low so that you have realistic, achievable goals that as you reach, it feels really good. And then you can gain confidence before you tackle a bigger project. But let's face it, that bigger project is what everyone, pretty much is really wanting. I mean, I know that that's what I was feeling when I picked up FUZE. I say picked up FUZE when we were making FUZE. When I started to learn to code, it was I just really wanted to run before I could walk. I had a lot of ideas for cool things. And then, gradually you sort of revisit those ideas once you're a bit more comfortable. And hopefully this stream will be a really solid learning tool for anyone who is at that sort of transition point where they feel like they've got a grip on some of the basic concepts and they want to move on to a bigger project, something a bit more, a bit more serious sort of thing.
So,
Mousey's Cheese Maze, I believe, is our vehicle for that.
Yes, it seemed to make sense. So, as Dave's just explained, we kind of got started with those fundamentals in the previous streams that we did together. I've actually still got my notes from the last couple ones that we did. So if anybody hasn't seen the previous streams and maybe wants to get a sense of what we did previously to get themselves up to speed, I would definitely recommend you go back and watch those as well. But for now, we covered things like loops, variables, if statements, arrays, functions, which, to read those off in a sentence is a very different experience to diving into them, because for a lot of those, it was my absolute first time encountering them. If you have ever wondered what any of those things mean, Dave did an exceptional job going through and explaining each one of those to me. But as most people on the channel,
thank you.
Oh, Dave, no, it was a treat to be talked through those by somebody who is so great at explaining those concepts, and you did such a wonderful job. I think most people on the channel who have been with the channel for a little bit of time will have remembered my game in Game Builder Garage that I was making since release. It took me like a year to make it, and most of that time was taken because I was really learning a lot of those concepts. Even, obviously, Game Builder Garage is a node-based game creation toolkit rather than code-based. But even so, a lot of the concepts there were completely new to me, and chat really developed that game along with me as we built Mousey over the course of a year, all on stream. So it made sense that in our little experiment here in making a game in FUZE, it should be something that people would be familiar with. I think one of the things that we have tried to do in those previous streams as well is, where possible, where applicable, because it's not always applicable, compare certain things to Node-on that are used in GBG. And I think that really helped me understand what the functions of certain things were. So to take that concept even further, we can kind of build something that is a little recognizable to some folks. But of course, we are going to be adapting it, and we're going to be working in ways that make sense in this new sandbox that we're going to be working in.
Yes, indeed. So setting some expectations out of the gate.
Yep.
I think what we should aim for, and this is actually probably just good sort of behavior, I think, to model for ambitious people as well, ambitious developers, is rather than, so let's say we want to make a game like Mousey's Cheese Maze.
Yep.
Right. It's a maze game where you collect items. There are hazards / obstacles. We have controls. We have a bunch of extra features. We have a boss, sort of final boss battle. And we have a bunch of different levels. Now, if we set our first goal of achieving a working first whole level with obstacles and everything, then we are really pushing that achievable point quite far away in time. And at that point, we might realize a ton of things that we'd like to do differently earlier.
Yep.
It might be that we have an idea for something that's going to work in a certain way, and we just sort of put it on the back burner, and we think, well, we'll cross that bridge when we come to it. We finally come to it, and it turns out actually we want to do it a different way because we didn't factor something in. So the best thing to do, what I found, is that you want to make a sort of a test level for something like this. So we want a very small, I'm thinking one room will have some walls, right?
Yep.
We'll have a character moving around. We'll have some items.
Mhm.
If we can aim to have something like that going, then we've got sort of confirmation of our ideas before we set our sights on a much bigger program.
Yep.
We also might, a much bigger level, and we might learn a few things along the way that inform our choices later. That's almost guaranteed to happen.
That seems
Absolutely almost guaranteed to happen. So I've just seen a question in the chat from Pizza here, and this is a good time to segue into how I'd like to get started.
okay.
Because I'd also like to use this chance to showcase a couple of the tools in FUZE.
Yeah.
And a bit of a methodology, not methodology, or maybe a mechanism, a way of creating collaborative projects by using the friend share functionality, which allows us to throw projects back and forth. And this is going to maybe make it a lot easier because as we're transferring, rather than you sort of writing all the code that I write and me also maintaining the same code again and writing it as we go, and we're going to use some custom assets. So that would require both of us creating them. Rather than doing that, we'll just one of us create them, talk through it, and then we'll chuck it over in the friend share, and then we can add to it, and we can sort of, do things that way. I think it really demonstrates, how you might also collaborate on a project in FUZE so that you don't have to go it alone, which is, let's face it, I mean, it's actually more often the case that games are developed in a team. And it's much rarer that it's just a solo individual. It does happen, of course, and some of the best games ever have been made in that way. But yes, to what Pizza here was talking about, I have a question. Can you use custom textures / drawings like in GBG? And you can. We can create our own textures. We can create our own sprites, our own tiles, and also create our own maps. And that's what I'm planning to do here. I think we'll probably start very simple. We'll use some placeholdery sort of things. And that's when I was saying I want to sort of get you to flex your skills, I'm thinking of your artistic skills.
Oh, okay.
I'd like to. Now, I've seen Mousey, so I know what you can do. Okay, I know the standard. So nothing less is going to surprise. No, I'm kidding. Yeah, so I'm going to guide you through using the FUZE image editor.
Okay.
And setting up the assets in this way and putting them into a project and that sort of thing. And then we can chuck it over. Maybe we can write some code to get that just confirmed and being seen on the screen. And then maybe we can throw it over to me. We can build a map and we can throw it back and keep adding to it that way.
Excellent. That sounds...
just to answer a couple more questions that I spotted as well. Mr. O, might be useful info. Mousey's cheese maze is not actually a maze. You won't need maze algorithms, and I am very, very glad to hear you say that because we were very much planning not to worry about maze generation algorithms at this stage because we want to do something that's a bit more like, showing you just how easy it is to combine these concepts that we've already looked at into a game project. And if we start diving into some really complex abstract algorithm stuff, like procedural maze generation, I think it's kind of putting more distance between, those who are looking to get started and this achievable, realistic goal area where I really want to, get people to look towards and to motivate themselves towards. Maybe in the future we can look at something a bit more complex like that. Once we're all a bit more familiar, and maybe when we've got a shell going in our game and we've made some progress. How do you feel about that, Dom?
That sounds wonderful. I'm so excited as well because I think viewers have had lots of questions about is it possible to make custom textures or sprites in FUZE? Is it possible to build maps? And the sharing too. I think specifically folks have been asking on the Discord whether or not it's possible to work collaboratively with other people. So it's really great that we are going to get an opportunity to touch on all or most of those as we're going along with this project. So really, really great. One thing I would say as well is I guess people will have lots of questions as we're going. So I'll try and keep my eyes peeled for specific questions and I'll read those out when we get a moment to do so. I'm itching to flex my drawing skills here.
All right, so we get started then.
All right, let's do it.
So what we're going to need to even begin using the image editor, because when you create images in FUZE or you create a map, everything is assigned to a project file. Okay, and that's something that we have to create in our programs menu there. and something that we can edit the information of in the project section of the main menu.
Mm-hmm.
So what we'll do first is we'll just make an empty program, which is going to store all of our images, all of our maps and everything. So if you go to the programs icon and select that, and then, yep, so we're in my projects here, and we can open up a new project, and let's call this Mousey's Cheese Maze.
All right, let's do it.
Or Mousey testing, or Mousey anything that you want, whatever you want, Dom. I mean, we're going to be going backwards and forwards with this, so we can always make new copies very easily.
I think. Well, first of all, there we go. I think for now we should call it Mousey Test.
Okay.
And then we can. It always feels good when you're like, oh yeah, these are working. You can kind of start to get it closer. But for now, it is
we can promote. We can promote it
exactly. It ranks up.
I've got you. Yeah, brilliant. Okay, so if we might as well put our names in here. Right? We can put Dom and Dave.
Right, there we go.
So that's how you know we're truly British and polite, is that when I said Dom and Dave, I put your name first, and when you wrote it, you put mine first.
Hey, well, we're both D names, but you're DA, so you gotta go first. Gotta be.
Fair enough. I'm not going to argue with alphabetized ordering. You know, who am I to argue that? Okay, we've been conditioned into that by 12 years of registers being called.
Mm-hmm.
Okay, and then in our descriptions, this is optional. I mean, if you want to get something in there, we can just put like testing ideas for Mousey's Cheese Maze or something to that effect.
All right.
Excellent.
Perfect.
And then we can press plus to confirm that, because enter allows you to enter more paragraphs.
Makes sense.
Of description. And now we're in our project. So we could start writing code here. We don't really need to right now. So what we're going to do is exit this with the minus button and return back to the main menu. And we're now, so Fuse always has a project open behind the scenes, and even before you've made one, the project that's open is sort of a default one. So we don't have to go and select anything again, but if we go to tools, we can now sort of open the image editor. We'll go image editor first, and that's right, yeah. So now it will ask you to select a project to create this image in. So all the images live in a project. You can also copy them to other projects and move them around very easily as well. But so if you select A here, select Mousey Test, that's it. And similar to the programs menu, we'll select a new image. And it's going to ask us if we want these three types. So I imagine the image we'll go for is a standard image. Okay. The tiled image is for if we want to create an animation. So we can say, I want 16 by 16 and I want 8 tiles, and it will lay that out for us. And you can also then edit the number of tiles. The font image is essentially a tiled image, but it has a predetermined layout of these tiles so that they map onto the text character values of a keyboard to allow for very easy use in a program. But keeping it very simple, we'll go standard image.
Okay. Great that you covered those, because that sounds really amazing. The idea that there is the option in tiled image to do animated textures or sprites, and then the idea of making a custom font, that's also very exciting.
It's something that the Fuse community have put to some amazing
I can imagine.
In fact, Steve Gaming, who's currently in the chat, I'll do a shout out there, because I think Steve may have single-handedly made more custom Fuse fonts than maybe anybody. Maybe everyone combined. Steve's got some amazing fonts that he's put into his games. Really cool retro flavors in there.
A font of talent. Sorry, I almost stopped myself there midway through.
It's good. It's good. Dave. I'm rapidly trying to think of another one, but I can't. And so, I will not. Nope, still can't. Okay. So, let's name this image something along the lines of, I don't know, Mousey. You can just call it mouse or character or player or mouse. I would recommend using all lowercase.
Okay.
And for the sole reason that it's easier to remember when we write the code.
Okay.
If we just, or all uppercase. If it's very consistent, then we don't have to remember ever again. We can just because we're going to have to load this image into our program,
Mm-hmm.
into the actual code itself by writing this file name, or
Right.
really, you can go and copy it as well. So there's ways around it all, but I think it's very handy to just do consistent casing.
Okay, so let's say we're
And
going to go all lowercase for this.
yeah, sure.
And I think player, so that we really know exactly what we're referring to.
Yes.
Okay.
Sounds good. Okay, so press plus. Okay, so you are now in the image editor.
Huh?
And there are a whole host of controls to learn and a whole host of tools and all sorts going on here.
Now I can tell you immediately, Dave. Everybody who has ever used Game Builder Garage is screaming with delight, I should say, shouting, shaking, crying, because they see box and circle tools. 2 things, line tools. 3 things that we do not have in GBG that makes making textures very difficult.
I was not aware of that at all, actually.
Yeah, I can see, Not Freddy in chat is saying, it's a line tool! Nintendo saying, a GBG user's dream.
I'll tell you what, I'm happy it's that way around, because if you're coming from, professional image creation software to this, then it is unfortunately going to feel like losing some functionality that you're very used to. If you're coming from something highly limited, then obviously, it's going to feel really great. You've got a foreground and background color. You've got very, very customizable things such as the line box circle. You've got a fill tool. You've got a magic wand. We've got copying and pasting of regions. We've got inversion. Flipping the image horizontally. All this stuff. You can do quite a lot with it. So, as you see in the upper right corner there, our image size is 100 by 100. Now that is quite large. And it depends on the context. It depends what it's being used for, right? Because in a normal game, that's really not very large at all. In fact, if you're talking about like a pixel art game of a modern standard, obviously some textures are going to be really quite large and very high fidelity. But we were talking before the stream about sort of what sort of assets we might use for the map, and you want things to look fairly cohesive. And so it's going to look strange if we have a really large image, very high fidelity, when we have very low fidelity tiles, very pixel arty, blocky tiles. Now, the tiles that we were looking at for the map later was, I believe, 16 by 16.
Yeah.
And I recommend that we try and stick to something quite a bit smaller than 100 by 100.
Makes sense.
It can be scaled, it can be changed, obviously, but I think we should at least go for maybe half the size of this, maybe even less. We could try maybe 32 by 32 or 64 by 64. And to resize the image, you're just going to put the cursor over one of the arrows that you see on the screen. If you want to do both dimensions at once, you can use the corner. Press the A button on that, and then you can adjust this to your heart's content, and it will update here. There is also a way that I forget. I actually immediately just forgot how to fix it to a particular width and height. There is a way to enter these values yourself, and for some reason I'm totally forgetting how, but you're managing it really, really well. Beautifully, actually. So let's do that. And we've resized it.
So there is also a way if you wanted to say, okay, for whatever reason, my texture is going to be 106 by 45. You could. You could enter those specific.
Yes, indeed. Yes, you could. Okay, so let's zoom into this so we can see what we're doing. If you hold down Z, I believe it's ZL. You hold down ZL, you'll see that the command bar updates at the bottom, and your right stick up and down is now zoom. This is the same as it is in the FUZE code editor. So it's the same way that we zoom in and out of our code. I recommend we do this just to get a good grip on what's going on. And I'd also recommend that we change our brush to a square, just for the sake of so this is in the top left, you see brush. If you select one of the arrows, and it'll change it to a square. And if you wanted to, you could change the size of your brush, or you could change the grid that you've got there if you wanted to see the squares a bit more clearly. You select the different tools using the L and R buttons. Color wise, if you press the Y button, you'll see our color wheel pop up, and using this you can select the color that you like, using the stick and the D-pad to do opacity and hue and saturation.
A color
And,
wheel as well. Dave, you have no idea how much of a luxury this is.
Really?
Oh, yes. Look at that.
And don't worry about finding the exact same color again either, because you can use a button to, once you've put a pixel down, if you then changed color somewhere, you could grab that color. It has like a color picker basically. So it's quite helpful for that. So your job now is to create the most endearing, most lovable character ever seen by human eyes.
All right. I think I can do that. Let's go for I'm gonna make perhaps the mistake of adding an outline. So the background is black. Okay, so we could go in and change that background so that this is a little bit more visible if I'm working with a black stroke for the outline.
Actually, that is something. So you've immediately hit upon one of the restrictions. It actually, if you are using the shades of grey that are similar to the grey background, it is actually it can be quite difficult to see. Now, there are ways around it. It's just that if you put any other color, then it won't be transparent, right? So if we did like a white background, and then we wanted to use that, obviously then the whole box is going to be visible as like a big white square when we use it for our sprite. But you could put the white background in, draw everything that you want, and then just remove all the white pixels. There's a way to do that, and you could use the fill tool to do it. But I'd recommend just, I mean, that seemed fairly clear to me. I think we can. And it's just a placeholder as well, as Bori has pointed out in the chat there.
I'm going to nail this first try. I'm not even going to erase anything. I'm just going to, it's just going to flow out. You know, it's going to be perfect. No issues. Here we go.
Question for Dave: are there any plans to add mouse support to FUZE to make sprite editing a little easier? We would love to do mouse support. It's been one of those things that's always sort of taken. It's never been sort of put to the top of our priority list because we've always had something a bit more pressing or something more desperate that we need to take a look at, something that we want to do, and so. Yes, there are plans to do it, but they are not immediate plans. I'm sorry to say, but it certainly would make it definitely would make sprite editing a bit easier. The Joy-Cons are going to feel strange to get used to, but I've seen what people are capable of in the FUZE community once they've gotten used to it, and now I believe that they're just superior. Actually, no, I don't believe that. I find them very difficult to use myself as well. But people do an amazing job with it. You can also use the D-pad to move by individual pixels.
Aha, good to know.
Which is, of course, much more helpful when it comes to sprite creation, sort of pixel arty stuff.
This is not my best work.
Very funny.
But I will, I'll call that a success so far. So
I think it's going to be very endearing.
Okay, good. That's looking a little bit more like a mouse.
Already we're off to the races.
Sort of. Is it an issue that I've drawn it pointing up? I didn't really know whether there was a need to...
I'm so glad that you've done that. I forgot to mention it, and I was going to ask you to do exactly that.
Perfect.
So that's brilliant, mate. That's really brilliant.
Let's give him a second color. I won't. I could spend. Clearly, this is like a first sketch. You know, when a painter goes in to view their subject, you know, and they go and they're seated in place. You don't want them seated there for hours and hours and hours and hours on it. Do that rough sketch and you take it back to this. You finalize it there. That's exactly what I'm doing. This will look flawless. It will be a perfect rendition of a mouse. But for now, we have this guy.
But for now, we have this guy. Mummy, can we have Mousey at home? We already have Mousey at home. Mousey at home.
Exactly. Okay. These are eyes, I promise.
Tell you what, it's not totally unterrifying.
Hey, I'll take it. So
dear.
if I was to... right. So if I press X over the color, that's how I grab that color. Is that right? There we
That's
go.
right. That's correct. That's
Nice.
correct.
Okay, I think the last thing to do is just give him a little nose.
Budget Mousey. This is like one of those bootleg versions of a character.
Chat, remember how terrible Mousey was on that first stream when I drew him? I can't believe that character managed to stick around, honestly. My first rendition of Mousey, Dave, was I mean, this looks like a masterpiece in comparison. All right, there we go. I think that's... Hang on, let me just fix...
Yeah, I was going to say, yeah, you can, not to be an art critic, where it definitely isn't my place. But
I mean, is there anything to critique here, Dave?
you know what? There isn't.
Exactly.
There isn't, is there? Perfection.
All right, that's looking good.
Which way is he facing? No, okay, this is now a lot. This is, this is getting much better.
There we go. I could
Yeah.
do some little fluffy bits.
Sure.
I think that's what they're called.
Yeah, that's.
Okay.
I think that's the taxonomical name for them.
Fluffy bits.
Little fluffy bits.
Mhm.
Yeah.
Okay, great.
Okay, amazing. Congratulations, Don.
Thank
You've made
you.
your first sprite in FUZE.
Whew.
Well done.
Yes.
I think you should be really proud of yourself.
Genuinely having access to, I mean, I haven't shown it off here, but having access to, a full color wheel is incredible. I defaulted to drawing everything by hand because I'm so used to doing that in GBG, but I also could have made use of the tools as well, the circle in the box tool, which would make things like drawing ears that don't look like whatever these are.
That is quite funny, yeah. It's like, wow, a shape tools. This is brilliant. Ignore them. Who needs these for round edges?
Exactly.
Not me. I think that is definitely bordering on the most endearing mouse I've ever seen.
Well.
It's like Jerry from Tom and Jerry, then this.
Yes.
You know?
This is the steamroller's gone past.
It's actually great. Okay, right. You happy to call that done?
Sure.
Okay, right. Let's press. Look at this advanced editor, Dom. No.
Yeah.
I love the chat. Brilliant. You got a great chat. Okay, we're going to press the minus button to save this image and return to the main menu.
Okay.
Cool. Right, so that's now in our project, and we're going to press. Let's just double check it, right? So we can take a look at that. If you go back into this, if you press A on the image editor here, and then we can press A on Mousey test. You can see that on the right it says player, and it gives you a little preview here.
Lovely. We've got a nice wide Mousey.
That is right.
Just to
Nice
remind
and,
us, yeah.
Hey, it looks pretty cute in the preview.
Yeah. Oh, I like having the preview.
Right, it is quite helpful. Yeah, and it has a pan. So look at that.
Yeah.
Oh, it's indistinguishable from the real thing.
The game's done.
That is it. Okay. Okay, right.
It's like one of those DVD screensavers.
It is, yeah. Everyone loves those DVD screensavers. What I find hilarious is that a lot of the workshops that I do, and we do this sort of the ball bouncing around like I showed on your stream.
Yep.
Kids of even like 10, they know about that screensaver, and I'm sure that none of them have ever seen it in context. Are DVDs even a thing anymore? I guess they are.
Got a new life in just like YouTube videos, I guess.
I
There are
think so.
definitely like hour-long YouTube videos of just the screensaver.
Amazing. Nostalgia for a decade that they don't remember is what that is. I think that's what we're all plagued by, to be honest.
Very true.
Okay, right. Let's go back to the main menu. That's BBB, and we will go into the code. And I think what we should do is just try and get a few lines to just see the mouse on screen. Let's verify that it's there before we start building a map.
Okay, I want to see the
We
mouse.
can get a bit of coding done. Yeah. So we'll go into the code, and we'll start writing some code here. I'd recommend making your text a little bit bigger. So use the same control, use the ZL and then up on the right stick to zoom in slightly.
Yes.
So that it's really clear in the chat. Okay. Great stuff. So we'll need a sprite that we're going to create using the create sprite function. And let's name that sprite player. Okay, just for the purpose of testing. So we're going to create a variable called player, which means just write the word player for me. So player equals. Okay, and then after that, we're going to use our create sprite function. Yeah, nice one for putting the space in. That's it. So create sprite, you can do the capital S if you want to do nice code formatting, right? Camel casing. It is a function, so it needs a pair of brackets. Okay. And this is one of those functions that doesn't actually need anything in the brackets. It's just, it is a function, and so it does need the brackets.
Yes.
Yeah, so this one is a very special type of function. We did touch on it a little bit in one of the earlier streams, but just while I've got everybody here as well.
Yep.
As soon as you've done this, lots of stuff now happens behind the scenes. Okay, when it reads create sprite, it is it's very, very different than just assigning a regular variable. So for example, if you just put a couple of lines in, for a couple of line of break, if you do like a equals 10, hey, this is assigning a variable, just like the one above it is, just like player equals create sprite, except this is assigning just a regular number, just a 10. Now that will assign an amount of memory, right? And it'll store this number in there. And it has this name that we've called A. Now that's all it is. It doesn't have anything else. It's just the number 10. That's a normal variable. But when you use create sprite, you get all this extra stuff behind the scenes. It gives you all these special properties that you can access using dots. So, for example, if you get rid of that a equals 10, and you write player dot x equals 100, okay. Now, normally, when you make a variable, like if I just made x equals 100, well, that doesn't do anything unless I actually use that x variable in something, right? Just because I've written x, it doesn't mean it's going to change anything. But with sprites, that's not the case. With sprites, it has these special properties like .x, .y, .x scale, .y scale, and those actually do change the sprite itself. And so it allows you to write very neat syntax to use sprites. It's really, really helpful. I just want to make sure that everyone is aware of that. When we use some of these things, this isn't the case for all types of variables. This is just because they are sprites. It is a special type of thing. Okay.
And Dave, am I right in thinking that partly one way that we can recognize that is through the color there, this pale blue on the create sprite function? Or is that
not quite?
Okay, apologies.
So the color of the create, no, it's a good question, and actually it leads me to think that that'd be a great idea for another feature. The color of the create sprite function is the same with all functions, right? So if you get rid of this line player x equals 100 and you write the name of any other function, for example, I don't know, len, len, right?
Yep.
And then in the brackets for this, you would put like an array or a name or a piece of text, and it would tell you how long that is, how many things are in it.
Yes. I think we used the end of the last stream.
Yes, we did. Yes, we did. The color blue there only tells you that it is a function.
Gotcha. Okay.
But it would be quite cool if once you've made player equals create sprite, if maybe sprites themselves had their own color, and then the code editor could sort of understand that that's now a sprite. But there isn't that is not the case. So the color here only tells you that is a function, and you're going to have to remember that the name player, that this variable is a sprite, and hence it has all these special things. Okay, so we've made the sprite. We need to attach an image to that sprite, because a sprite is more just like a special area of memory, like a special chunk of memory, which has room for all this stuff to be put in it. You know, it's got an X position, a Y position, it's got a zoom, sorry, a scale on the X and Y axis. It's got a speed, it's got all these different things. And one of those things is an image. And so to see anything on this sprite, otherwise it's just blank, we need to assign an image. But before we assign the image, we need to load that image. So we need to do two things. Load your image from your project media into the code itself. And so it has a name that we can refer to. And then we need to use that image for the sprite. So we'll do this before the player line, actually. Could you just make a line above player? And we'll call it player image, just to keep the syntax nice and clean. And so player image equals, do a capital I just for the sake of it. Yeah, player image equals load image. And so we're using a function called load image, and this is going to load an image from our media. And in the brackets for this, we need to put the file name. And we know that the file name is just player. So if you put that in the brackets, now you could just type player in speech marks, that is done as well.
Yeah.
Because we're giving it like a special string, like this is a file. This is the name of a file, not the name of a variable.
It's referencing that specific name.
Yes, and it's going to say, okay, load image player. Well, where am I going to find that? And it's going to the media for this project, which is the one that we made in the image editor. And there's only one image in there. It's called player.
Yep.
And it's going to load that into this variable player image. So now we can use this player image word in our program wherever we want, and it's going to be quite helpful. So we've done that now. Underneath player equals create sprite, we'll do set sprite image. And in brackets, we need two things. Yep, no worries. You get very used to doing that.
In brackets.
Not equals, we need, that's right. So two things in here. That is the sprite that we are setting the image for, which is going to be player. And then a comma to separate this from the next thing. And then the image that we're setting. So we're going to go with player image. The image that we have loaded in and stored. Right, that's now done. And we're ready to now write a little main loop for our program, which is going to display this sprite on screen. And so our main loop, I recommend that you put 2 forward slashes here. And let's write main loop.
Okay, so this is going to be a little comment for
a little comment, yes, so that we can remember where things are in our program, which is really nice and helpful. And yes, because it's a comment, it doesn't abide by any sort of formatting rules in the text. So you can have spaces, you can have whatever you want.
Great.
So underneath that, we'll have loop. And then give yourself a space, write repeat. So on separate lines, that is.
Apologies.
So just if you go before the hit enter a couple of times. So you've got some space, that's it. In the loop, we are going to need a few basic things. So the basic game loop needs to do just a couple of things. It needs to draw to the screen, right? And if we've got animations going on, then we're going to want to clear the screen so that we don't see all of the old positions of everything, and we have the weird trail that's being left. If you remember, I think it was in the first stream.
Yes.
We had like a trail being left by our sprite, right? So we don't want that to happen for this. Obviously, it might end up with some cool stuff later. We can try it out, but we'll do 2 things. Well, actually, no, 3 things. So if you could press tab so that you're in by a little bit, just so we're nicely formatted. Again, I'll just reiterate for the chat. It's optional in FUZE. Formatting your code in FUZE really doesn't actually matter as long as it is being read correctly, so it's spelled correctly, the spaces are there when they need to be. But in terms of indentation, it really doesn't mind. This is for our benefit and for the benefit of the readers as well, to keep it nicely formatted. And so the 3 things we need to do in this loop is to clear the screen. So if you write clear for me, that's a function. And so we'll put a pair of brackets there. We can put something in the brackets if we want a background color, but let's leave it black for now. On the next line, we're going to draw sprites. Draw sprites. Nice. Look at that. You're learning so fast. Camel case, no problem. And again, pair of brackets. It is a function. This function draws every single sprite that we have created.
Okay.
So for the purposes of this program, that's fine because we've only got one sprite and that's all we want to see. If we had a bit more of a sophisticated thing going on and we only want to draw certain sprites at certain times, then we'll need to maybe do this differently. We could draw singular sprites instead of just draw all sprites. Maybe we have a loop to draw a bunch of sprites in a particular place here, then somewhere else in the drawing queue, maybe we have something like a mini map, and we want to draw some sprites on this part of the screen, but not on other parts. This is where you might want to use draw sprite as a singular, and have that done out in a different way. Anyway, the last thing that we need to see is update in our loop, because without this, we don't actually send any information to the screen and see anything going on. So this is your basic game loop. All it does is it puts something on the screen.
Yeah.
If we run this, we should see Mousey in the middle of the screen looking very, very small indeed.
Okay, let's see if we can spot
try it.
A very tiny Mousey here. There we go.
There we go. There we go.
Is that that's at real scale, is that the 32 pixels by 32?
Exactly right. That is 32 pixels by 32 pixels at the correct scale 1:1. So you are just seeing the size of 32 pixels there.
Wow.
Now, there's a few different ways that we might want to make things bigger or change things around. 1 second. Just blow my nose. There are a couple of different things we can do. We can change the scale of the sprite so it is actually being drawn bigger. Or we can zoom in on our camera, because whenever we're using sprites, there is a sort of behind the scenes, it's always there. Even if you don't tell it to be there, it is always there. There's a camera. If you imagine that you are looking down at sort of a piece of black paper with the mouse sprite on there, you're looking through a little camera at that. Okay. That is kind of always there implied. And so we can actually adjust the zoom on that camera, or that camera's Z-axis position, to zoom in. Now, this is probably going to be what we want to do. I think it'd be good to just introduce that actually.
Okay.
So if we let's add this line to our program. So if we that's right. We'll just put this before the main loop for now. The main loop for now, because eventually we'll probably want the camera to be moving around as we move the character around and move around a level, but we don't need to worry about it yet. This is going to be set sprite camera.
Oops.
That's it. And in the brackets for it,
I think I have my finger like one key over. Okay.
Yeah, no, I know what it's like. Set sprite camera, and in the brackets for this, we need to give it a special type of thing. It's a vector.
Okay.
Which is sort of one or more numbers treated. Usually two or more numbers treated sort of as one object. It's as simple as just a pair of coordinates. Okay. It's a fancy way of saying we need some coordinates in here. And vectors in Fuse always use curly brackets. So can you put a pair of curly brackets? Yeah, the ones just above the square brackets. That's the one. That's the one. And in these brackets, we need to give it an X, a Y, and a Z position. So X is going to be where it is positioned horizontally. Y is going to be positioned vertically. And by that, I mean sort of if you're looking down at our little view, right? If you move your hands left and right or up and down on this little screen, that's what X and Y is doing. But if you change Z, you're actually changing how close the camera is to the canvas, if you like.
Yes.
Right?
Yeah.
So we're going to put 0, 0, because that is the center of our world when we're talking about sprites. So that's our X and Y position, right? We're positioning the middle of the sprite camera in the middle of our game world. That is also where Mousey currently is. His X and Y position is 0, 0.
Yep.
So we're positioning the sprite camera so that the middle of the camera is right on Mousey. And this last number is the zoom. So a zoom of 1 is going to be the current zoom. So
that's
if we
what we're at now.
That's what we're at right now. If we run that, there'll be no difference, or there should be no difference. Let's test that. Yeah, brilliant. So now if we put a 3, for instance, this will be 3 times closer. Everything will appear 3 times bigger.
Yep.
Right. And actually, that sprite is looking better and better every time I see it.
I think you're desensitizing to it.
I think that's one way of putting it. Yeah, sure. It's growing on me. You're being desensitized. Sure. Yeah. So this vector here, right? This 0, 0, 3. This is eventually going to be a variable that changes and updates in the program.
Right.
Because we're going to we might want to move it around. We might want to zoom in and out. There are very much reasonable things to want to do in a game. But for now, we're just happy to just sort of position it where we want it so we can see it. And I'd like to just answer a question from Lucian in the chat, actually. So 0, 0 is center. What are the outer bounds, the largest numbers that are still on the screen? That's a great question. And you've updated it afterwards with the answer I was going to, or one of the answers I was going to give, which is it depends on the zoom. And that's absolutely right. Now, at the default zoom, the outer bounds are going to be half of whatever resolution you are using on each respective axis. So what do I mean by that? Let's say that you're using the Switch in handheld mode, right? And it's 1280 by 720. So 1280 on the x-axis, 720 on the y-axis. Pixels I'm talking about here. If we put 0, 0 as the center, then instead of going from 0 on the left to 1280 on the right, what we've done is we've shifted along by 640 pixels. So half of that, which means that our left side is now minus 640 and our positive side, our right-hand side is 640. The same applies to the y-axis. We've got minus 360 and 360. But as soon as we zoom in, suddenly that will change. So we would have to factor in our zoom into these numbers using some simple math, basically, in order to calculate what those outer reaches of the screen are. Okay, don't worry about it too much right now. If we need to, we'll get into it later, and just update. So 1280 720 is default Switch handheld resolution. That is correct. At least that is what it's doing in Fuse. A lot of games do not use that resolution because they might be doing some very complex things. If the game is doing a lot of very sort of serious heavy lifting, then it might go down to 540p. I know that some games use that resolution as well. So it's like Scratch's positional data. Yes, what we're talking about is an X and a Y position for our camera. We're talking about the middle of the camera there. And I think that answers all the questions there. Okay.
Perfect. Yeah, that makes a lot of sense to me. So at least when we're referencing the sprite, 0, 0 in those first two here are going to be our X and our Y on the left and right, up and down on the screen. If we were to think about the far left of the screen as going into the negatives, because 0 is right bang in the center, on a default zoom level, we're halving the resolution of the screen.
In fact, I can actually just quickly make this very visual. If you press F1 on your keyboard, there's a document in Fuse which I made to sort of explain some of this. So if you go down to command reference there on the left, and then press A, and you want to go to the document called Sprite System.
Yep.
At the bottom there. And that will make this very, very visual. So you can see that we've got, this is the center of our map if we had a map, or i.e. our game world. So there is it's pretending that there is a map right now, right? It's just black, it's just there's nothing there.
Yeah.
So that's the center of our game world. If we zoom down a little bit, sorry, not zoom down, scroll down, that's what we're doing with our sprite camera.
These resources, having these inside the editor is so handy, just so immediate, and they're so excellent. Having the visual reference in here as well as the written references makes understanding this stuff so immediate.
I think that's one of the things that we're very proud of in FUZE is the self-contained sort of learning suite that it has. And also, when we were making FUZE, I kind of was thinking, oh, everything must have this. You need to have this. And what I've realized is actually this is one of the things that sets FUZE apart quite a bit, is that its resources for the information, the documentation, are quite a bit more accessible than quite a few other programs. I'm led to believe, or I'm led to understand now. So this will now talk about everything to do with sprites. The sprite properties. It has a list of all those special properties that I mentioned. It talks about how to, set animations for sprites and that sort of thing. And you can look into more detail about any one of these functions on the actual dedicated page for that function. So all the positions, all the position properties, and then you've got all the size properties, all the scale properties, that sort of thing.
So I suppose if you were
explaining it all.
Sorry, Dave. I was just going to say, so I suppose if you were trying to get a sense of what is possible with the sprite system, there may be things that you didn't even realize that could be done.
Absolutely.
I mean, I'm looking here and I can see that color properties are a thing that can be done after the sprite's created.
For example, if you wanted to have a sprite flash red, let's say that you got damaged by something and you wanted it to flash red or to just turn red before it faded out. Let's say you were making like a turn-based battling system like Final Fantasy games, like the early ones, and they sort of turn transparent and red, right, when you kill an enemy, and it goes. So what you would do there is you would just decrease the green and blue properties, leaving only red. And you'd also decrease the opacity or the alpha, the .a. So if you just reduced green, blue, and alpha, it will go red and transparent. So it's making those sorts of little things easier to do. That is the idea behind the sprites. Because you could, using just code and structures and functions, you could create your own sprite engine. If you wanted to. Right. And many people have done something very similar. People have even created their own 3D engines in FUZE, which is a whole nother kettle of fish. But it's just there for that accessibility. And it's also something that a lot of other sort of game creation toolkits have, is something like a sprite-like system. So it's, Well, I mean, and having it be affected with the map and all these integrated functions for colliding with things, as well as we'll get into later, are really helpful as well. So you'll get to see more of that as we go.
Good stuff.
But yes, to exit that, you can press minus, and that will just quickly close it all down. Okay, so we're seeing our sprite. Shall we? So I'd like to give you a choice of where to go next.
Okay.
We can either we can either get it moving around, add some controls quickly. Or we can look at creating a map and chuck the project back over to me and do it that way. But I mean, we're going to be adding controls at some point anyway, so totally up to you.
They both sound wonderful. I could kind of go either way. I mean, I think it would be nice to test out being able to send what we've done already to your Switch as well and see.
Yeah, sounds good.
Yeah. Okay.
Yeah, sounds great. Okay.
So this was the sort of collaborative tools, the sharing that you mentioned at the beginning. And as I said, I think people on the Discord had been asking about it previously. So yes, I think this would be great to highlight.
Okay, fantastic. Yeah, so it should be, fingers crossed. Obviously, we did some testing earlier on, and provided that the technological gods are kind to us.
Yep.
Should be quite an easy process. So let's let's return to the main menu and press minus on your end. We've got our project done. It's all saved. It's got an image in there. What I'd like you to do is to go to your programs section. We're going to go to the thumbnail for your program, Mousey Test. And we're going to press the X button on that, on program options. And we're going to select share program. So this is the first step of how you would get a program shared using the download code system. It's what we do in the game jams in terms of submitting the games for me to stream and download to my Switch. But this half of it is just for our friends. So when you select share program, it uploads it to a folder, which is your shared programs. And by default, all of your Switch friends that also have FUZE can access and download from your folder without any permission necessary, because you've, made the choice to be Switch friends with them, for better or for worse. And it's only when you want to have it totally publicly shared, downloadable by anyone that you can give an ID to, in which we would need to then confirm and moderate that. So
Gotcha.
when you select that, and I'll show you how to do that anyway, just for the benefit of those at home. So if you press minus now, so we're going to return to our main menu, that's now shared. And we're just going to double check that it is in fact in your shared programs. So if you go to the share section, and fingers crossed it loads nice and timely, this can, great, okay. We're going to press, so this is the showcase gallery. And then this is where you can download the projects that are currently being showcased in FUZE right now.
Including
if you press the R button,
a couple that I recognize from your previous jams.
Yes, yeah, the piece of cake was absolutely phenomenal.
Yes.
If you press the R button, that's going to go across to our friends list. If you press it again, then you can see your shared programs. So we've got a few here. So there was the one that we did on stream 2. There's the one that we were testing out earlier, Dom, and then there's the one that you've just put in here. Now, if you select that Mousey test with A, here you can either re-download your own program. So if you deleted it, you can get it back.
Great.
You can choose to unshare that, or you can submit that to live, download code sharing, in which we would approve it or reject it, and then you would get an ID that you can share that with the world. So we don't need to select anything here. I'm just letting you know that's possible from this menu.
So am I understanding?
Sorry.
I was just going to say, so am I understanding correctly that by sharing with friends, it's a great way of either showing off something to your Switch friends, or maybe if you're collaborating, and then if it comes time to, you think, you know what, I'm ready to make this available more publicly, you can go here and you can choose the submit option for it to go through, that bit of moderation. Make it available for everybody.
I mean, it's also it's the way that you want to do it, because if you it's a lot to ask for you to make Switch friends with somebody if you don't really particularly want to. And so if you don't want to make friends with them via the Switch friend system, and you want to just be able to send a game code to anyone, well, then that kind of then involves us a little bit. Because obviously Nintendo don't want certain content, and neither do we, being sent to anybody without any any forewarning. But obviously, if you are a friend with somebody on the Switch friend system, then there's already been that connection there.
Gotcha.
So it's kind of in your hands at that point. But if you're not doing that and you'd rather not have Switch friends on your console, that's absolutely fine. It's just that we need to then approve the program. Okay, so that's now in your shared programs. I now need to access your share folder.
Okay.
So that I can download the game.
Let me know when you'd like me to switch over to yours, Dave. I'm not sure.
I think that it might be a good time to do that, actually.
Okay.
I'm just making sure that I haven't got any programs with the same name of Mousey Test, and I don't. So, yeah, if you switch over to mine, then I can do that.
There we go. So we're on Dave Cam now. We're looking at Dave's Switch.
Excellent.
I have the green menu. Dave's got the blue menu.
Yes, that's right. Yeah. Now, for some reason, my share section just takes longer to load than yours. I think maybe because you've got some sort of powers that I just don't understand, because mine takes ages to load.
I'm using the unreleased Switch Pro.
Super quick. So yeah. That's just be like that sometimes. So I'm going to go to the DOM section here and Mousey Test. I can see your programs here, and I can go download that project. I might as well open it now. And bam, we've got the code. I can run the program, and there's Mousey.
There we go. So that's gone from my Switch to your Switch.
That's right.
Including the sprite, including the code. Amazing.
That's right. Sprite, image, and everything. And so now I could add some content to this. I could write some code to it and send it back to you. Or I could do what we're going to do, which is to make a map and show off the map editor a little bit, I think.
Nice.
So, actually, you know what? Before we do that, I'd like to get the sprite moving around in this black space here.
Go for it.
Because otherwise we're going to I just want to sort of show it in these very, very gradual steps, so that we have it moving, then we put something in there, then we'll restrict the movement based on that. So this is from Lucian. So how does the share work? Does the Switch act like a server where it's only available while the Switch is online? Or is there a server elsewhere? We have a server that we maintain, Lucian. And so it doesn't have to be online. Their Switches don't need to be online for you to download their program. Obviously, it just needs to be online for actually uploading the first program. For uploading the program in the first place, what I meant to say. Okay, so we're going to quickly just write a little bit of code to move this sprite around, and I'll show a couple of things. So I'm going to add to the main loop here. And just some general bits of advice. Now I've just pressed tab, expecting it to tab on the keyboard, and instead it just changed windows. So let me just change my keyboard over. There we go. So in your main loop, there are two sort of things that you want to be mainly doing, right? You want to split the task of your game into a couple of things. Now we might sort of really rewrite this as we go because it's obviously just a bit of a test, but we do want to start kind of as we mean to go on a little bit. When we write a main loop, we want to split these two aspects of our processing. We want to have the game logic. By that, I mean updating things, checking things, etc. And then we want to have the game draw or game drawing.
Okay.
So we want to figure out everything, right? Check everything, collide with things, do all the logic of things, all the collisions, all the stuff. And then lastly, we're going to draw all the stuff. The reason we do this is so that when we come to debug the program and we see a problem with our drawing somewhere, or we see a problem with our logic somewhere, we know where to look straight away.
Right.
If everything is sort of wrapped in together with, now obviously at this point it's kind of hard to imagine that, but when your main loop is getting quite sizable and you're doing all sorts of stuff, you don't want to be like drawing something nested in a bunch of different conditions and with some other logic going on, because if you don't see it on the screen, it's kind of hard to know why that's happening. You want to instead have everything nicely separated, logic, drawing, logic, drawing. Sometimes that rule gets a bit suspended. But I want to get us thinking in that way. It's not super important for a beginner, but I'm here to sort of fast track you a little bit in terms of starting and maintaining a larger program. So I'm not going to guide you through all of the pitfalls. Let's start as we mean to go on.
Yes.
So game logic. One of the things that we're going to do in our game logic is to get the state of the controls so that we can use it in our program. Now, I like to make these global variables because as we go through the project and we write functions for everything, which we will end up doing, and we're going to organize the project into many different functions, we want to be able to use the controls and access them from basically everywhere in the program so that we can always check what the controls are doing. And we might end up localizing that to a particular function that just checks the inputs, but we're going to do this just to sort of cover our bases. And so I like to make these global controls variables.
I can immediately see why that would be useful, because even in the small projects we've done so far, having these variables that you can adjust without having to go in and change every single iteration of it in the main code has proven so useful. I think in the little quiz that we made, that was very evident as well.
Yes, that was. I mean, that was also just the benefits of just using variables at all. I mean, if you use variables, it really allows your program to be maintained in a much more efficient way. But you see, the thing is, if we write this C equals controls here, right, this is what I'm getting at here. If I put this in here, you see how this is the first time it's defined, right? C doesn't exist before we enter this line here. That means I can only use it in this loop. Okay. So that might be okay for a very small program, but if I've got some function,
right,
I've got some function later on which is just doing some tasks. Maybe it's checking something, and at some point in this function, I want to know if the A button is being pressed.
Yep.
Well, this won't work.
Yeah.
Because this C variable was not declared in the same scope as this function.
Got it.
Using a term there that is a bit more on the advanced side, but this is scope.
Okay.
When you enter a function or an if statement or a loop, you are changing scope. And you can kind of think of it as like the context that everything is in. So when we make a variable here, right? This exists in this function's scope. Okay.
Right.
And I can now use this anywhere in this function, but I can't use it somewhere else. So, in the interest of having our controls accessible everywhere, I like to make a global variable so that whenever we update this variable, we're actually updating the main sort of master controls variable, which we can access everywhere in the program.
Yeah.
Okay. So then in the main loop, instead of creating this variable for the first time, we're actually just updating it with whatever the controls are doing.
Yeah.
So this now becomes like the latest, at the very, very beginning of the frame. So remember this loop, one iteration of this loop is one frame of our game. The very, very beginning of the frame, we read what the controls are doing. And then for the rest of our entire program, no matter what we do, we know what the controls are doing at the beginning of that frame, and we can use them anywhere we want. Okay, so get the controls. Then we're going to move our sprite around. Now, we could do that with the following method. We'll take player, take the player X position, and we'll add to that the left stick X-axis value. All right?
Okay.
Did go into this a little bit before.
Yes. I think you were moving around a spaceship.
Yes, that's right. We're moving a spaceship around. This .lx is a number that goes from 0 to 1, depending on which way we're pushing it. In fact, do you mind if I just... Because I'm aware that we're going over a bunch of things here that might be sort of going a bit quickly. So if you don't mind, just let me know if this works. I'm just going to change my feed here to be my desk.
Yeah, that is working perfectly.
Can we all see that? Yeah. Okay, it's time for some drawing with Dave. Okay. And what we've got here, I'm just going to draw a nice thick pen. Let's say that this is the stick right here. Right? This is the stick, this circle. And in the middle of the stick, so when we're not touching it, we have a value of 0. Okay. So this is 0, 0 in terms of the X and Y position.
So the sort of resting position of our analog stick.
Resting position of our analog stick. As we push the stick this way, right, to our right, and I apologize for being left-handed here, so I'm just going to cover everything that I'm doing. It's the curse I've lived with my whole life. As we push the stick over here, its X-axis value is going to move towards the number 1.
Yes.
Okay. And in between that, we're going to have everything under the sun, 0.5, 0.9, 0.38216, right? Tons of precise values between these things. As we move the stick over to the left, we move towards the number -1.
Right.
Okay. As we move the stick down, our y-axis value will change to -1. And as we move the stick up, the y-axis value changes towards 1. So these two numbers, .x and .y, that is what, when I say we add the stick value, that is what we're adding to the X position of our sprite.
Gotcha.
Okay.
So in some ways, it's a little reminiscent of the sprite position where, you know, as it went to the left, it went into the negative, it goes to the right, it goes into the positive,
That's correct.
and 0 is our center.
That's exactly right. So let's just remind people what we're talking about there. We're talking about having a screen, right, in which we've got positive values toward the right on the x-axis, negative values toward the left. And as we move our sprite this way, its x-axis value is increasing, right? It's being plussed to.
Yes.
As you move it this way, it's decreasing. So it's really handy then that the stick is -1 toward the left. All we need to do is just add the value of the stick to the x-axis and it will move correctly.
Gotcha.
So,
Dave, a quick left-hand update. Seems like the majority of the chat is also left-handed, so you're in good company.
It's funny that is. That's really strange. What I really like about that, what have I just done on my screen? I've just totally there we go, right. I just changed over to my video feed on on Discord, and it flipped my image over, and it showed me both mine and yours, which is also mine, but mirrored. It was very confusing.
Oh dear.
Okay, the L letter here
Yep.
is the left stick.
Ah, okay.
Right?
Yep.
And if we wanted the right stick value, we just put that. So that is the C variable. This controls function is a little bit like create sprite in that it returns to us a special type of data that has all these extra properties like .a, .b, .r, .l, .zl,
Yep.
.lx, .ly. Okay, so we're going to take that and add that. We're going to take our y-axis value, and I'm going to minus the right, our c.ly. And then the reason for that is because the stick moves toward negative as you push it down, whereas the screen itself is negative toward the up. There's a couple of reasons why this is, and you kind of have to compromise on one way or the other. You either have it just move, down with positive, or you make some maths that uses the control stick values a little bit harder. I don't want to go into too much of that. It's going to start going into some more advanced math stuff. But if it seems a bit counterintuitive, believe me, there is a good reason for it. On the left-handed thing, I recently ran a poll on the Discord, in the FUZE Discord, and it turned out that there is an overrepresentation of left-handed people in our community as well, which I found very interesting. There's also quite a few left-handed people in my kendo club, weirdly, as well. So I think I'm a bit of a magnet for all the lefties, maybe. Are you yourself left-handed, Dom?
I'm not. No, I'm the odd one out here. Yeah, I'm.
Oh, the odd one out.
I know.
Finally. How does it feel?
Yeah, I just feel so ashamed.
That's funny. Okay. Okay, so we're adding our stick values to our play position. If I run the program, we'll see Mousey move. But it is going to be quite slow. We're only adding one, right? We're only adding a maximum of one.
Right. Yes.
To stick around.
Yeah.
So it's not very much.
So every value that is going to be sent from this controls will be between 0 and at its absolute extreme. If you slam the stick to the right-hand wall, that's only ever going to give you 1 maximum.
Correct.
And everything in between, but no more than 1.
And if I really gently push the stick, you can see it's very, very tiny movement. So because it's a limit of 1, if we want to make it faster, we can just multiply this by a number. Multiply it by 2, make it twice as fast, right? Multiply it by 10, make it 10 times faster. Now, this is one sort of type of movement, perfectly valid, right? This movement is going to work for us. We could make it a little bit more sophisticated, and I think this is a really, really nice little technique, and it doesn't take very long at all.
All right, let's see it.
So what we're going to do is create a couple more variables. Okay, a couple more variables. Now, the sprite system, you know how you've got this... these properties that are made. So we've got player.x, player.y, and they actually do stuff. One other thing that you can do with the sprite system is you can make your own. I can say player.my amazing value equals 1, and now I can use that in my program.
Okay.
This is a totally unique feature of sprites. Okay, normally if you try and use a variable that does not exist, it will of course cause a problem. But in sprites, if you assign a variable, like a property that you haven't used before, if you basically assign one, you don't have to have pre-created it. You don't have to say, oh, this sprite is going to have this property, this property. You can just freely make them, and then once you've made them, you can use them. It's very, very, very useful for creating custom properties like player.hp. Just to represent it that way.
Yeah.
And then it becomes part of the sprite rather than having to have separate variables. Player HP equals this. I mean, you can do it this way as well. It's absolutely fine. But if it's all part of the sprite, it's very efficient because the sprite is this like one single memory location. Without getting too technical, that's part of the reason why. Okay, so we're going to make 2 variables, one for x velocity and one for y velocity. Now, FUZE actually has these. the sprites actually do have a speed property by themselves, and I'm wondering if we should just use that instead, or I might just I think I'm going to do it in this custom way because it's kind of it really gets it across nicely. So
Okay.
and it just sort of shows that it's nothing that really is anything fancy behind the scenes. I'm going to make player dot. Now I like to use underscores, so I hope you don't mind. I'm going to do vel x.
Mhm.
Okay, and player dot vel y. Okay, so we're going to start these both off at 0. These are our velocities, right, for our player. So it's going to represent the speed that we're moving in a direction. And instead of adding to our x and y values of the player, we're actually going to add to our velocities instead.
Right.
Now, because we're doing that, we don't really need to do this anymore. Well, we could actually. We could leave it in there. It's just going to be quite a lot faster. So we'll come back to it. We might want to add it again, but for now, we're just going to add these values. So now nothing will happen, right? We're not going to move anymore because I'm moving the stick here. We're not going to move because these are custom things that we've made. They might as well say player dot, socks plus equals this, player dot something else. Right? They don't do anything until we use them. So let's use them. We're going to take our x position and add the velocity.
Okay.
And then take our player dot y position and add the velocity. Okay? So now we will move, but we're going to have that infinite sort of slipperiness movement.
Yes. Yeah.
If I just push the stick and let go, we are now flying around forever, sliding around on like the best, most polished curling surface you've ever seen.
Yes.
Right? And so the last part is that when we let go of the stick, we want it to reduce. So it gradually comes to so it gradually tends towards 0. And so we're going to take our velocities and we're going to multiply them by a number that's less than 1. So 0.9 is a nice way to start. Player.yvel times equals 0.9. And now every single time we read these lines, it's going to get slightly less. Yeah. So as we're pushing the stick, we're adding a velocity of 1 to both directions, or to whichever direction we're pushing. We're then adding that velocity to the player position. And then before we read the next value, we're reducing it. So as we're pushing the stick, it's only ever moving at a maximum of 1.
Yep.
But then when we let go of the stick, it will gradually reduce in velocity. Oops, what have I done there? Oh, it's vel x, vel y, not x vel. Silly me. Vel x, vel y. Like so. I got them wrong there. And so now when we let go of the stick, it's going to do this nice slowdown.
Great.
And this might be what we want for the mouse. We could really customize this if we want it slightly. Like little changes here will make a big difference. Right, that's going to slow down slightly quicker, maybe like 8.3 or something. I'm not sure. Maybe just 8 will do. Feels quite nice.
Yep.
Okay, right. So that's a very nice movement system for our mouse.
So we now have that kind of ease out of a movement with the vel x and vel y.
Exactly that. It's instead of just coming to a complete stop and reaching 0 as soon as we let go of the stick, it is as soon as we let go, the velocity gradually reduces, it eases out until it reaches 0 finally, and we've come to a halt.
It's a little.
It's a really nice style of movement, and it's used all over the place I'm sure that you recognize it is used in so many different contexts for a lot of different sort of types of movement. It's really a very simple physics system. It's not, it's kind of a bit silly to call it that because it's so basic, but it's not technically incorrect either, because you are actually writing physics in code is just representing the forces of physics using numbers. That's all it is. We're just creating a representation of the way that things in the universe behave and representing that with numbers. I mean, it's what physics and maths really are, and it's just using code to do that and then to apply it to a context like this, which is very visual. So it is friction, it is inertia, it's momentum.
Yeah.
It's this number is the slipperiness of our floor, or the friction of our floor that we're moving on, right? If it's closer to 1, super sticky floor. If it's closer to 0, beg your pardon, super sticky floor. If it's closer to 1, very, very slippery floor. Okay. The last thing I want to add to this is is a very, very quick and very helpful, but it's going to invoke a function that might sound a bit confusing.
Okay.
But this is how to make it point in the direction that we're moving.
Yes, because right now Mousey's sort of strafing around.
Exactly.
And,
Don't know if you've ever seen a mouse move in real life, Don, but this is not how they move. I'm telling you that now. It really isn't. It'd be very odd if it was.
It's just very, very focused on whatever's off screen to the north. It's just
exactly. And so this is something that you're probably going to want to do in your programs as well. And so what we're going to do is we're going to use a maths function called ATAN2, which is rather a fancy name. We're going to take our player rotation value, right? This is what we're actually changing. If I change this, it's going to change the way it's pointing. If I put +=1, right, it's going to be rotating like this all the time, which is going to look and feel even weirder if we move it around. So now he's like a sentry gun of a mouse.
Yes.
And so what we want to do is
floating in space.
Yeah, sure. Yeah, someone's just sort of flicked him on one side and now he's forever spinning. And we want to assign this a number rather than adding to it. We want to assign to it. And actually what you do is this is all you need to do. You take the LX and LY, so the stick values. You take that X and Y value, you plug it into ATAN2, and it will point in the direction
look at that.
chase. You will also see this other problem, which is when you let go, it reverts back to normal.
Because it's only taking those values when you're moving the X and the Y on the stick.
Actually, that's what we want it to do.
Oh, right. Yeah.
It's doing the opposite of that. It's always using the values.
Yes.
And we only want it to use the values when we're touching the stick.
Right, because it's using the values including 0.
Exactly. We're feeding it zeros. And so it's always just going to get us. So I'm just going to, just to make this more clear, going to go back onto my webcam view here, go back to the old maths book, and just show you what that function is actually giving you. Okay. ATAN2 is taking, let's say that we've got a graph here, right? And we've got our stick value. So this is actually getting more into why we use the negative going down here on the stick, because in all of our math functions, this tends to be the way around that it is all laid out. So let's say we have a graph here, 1 towards here, -1, -1, 1, right?
Yep.
So this is what the stick is really representing. And you can imagine a circle with a radius of 1. I know it's a great circle I've drawn there. So please, it's even worse than the Mousey there. But yeah, so we have a circle, right, with a radius of 1.
Yep.
Okay. When we use ATAN2, we're giving it an X and a Y position, and that X and Y position is going to be somewhere in this region, right? Let's say that we are giving it this point here. Right. So we're pushing the stick right here. Well, what ATAN2 does is it says, okay, how much of an angle is that from our default point? And ATAN2 just returns this number of degrees. And so it tells us the rotation angle that something will be given an XY coordinate in this unit circle graph. Right?
Yep. Okay.
And so we can use that to great effect for all sorts of different contexts. I'd like to demonstrate that because if you don't know what that's doing, it feels like a very sort of out of reach function to use. And as soon as you start thinking about it in that context of, I've got a circle with a radius of 1, that's my stick. And if I want an angle of rotation, that's what this gives you. How it does that is you don't really need to concern yourself with, because that's why the function is there. But otherwise, we'd say you have to do this for yourself every single time.
Yeah, it's definitely wonderful to know what the ATAN2 is doing in the background, though. Not necessary to use it. You know, you can just refer to ATAN2, but really, really fascinating. And I'm sure chat is. I know many people in chat will be interested to have seen how it actually works out value.
Well, I definitely haven't shown you how it works that out. How it works it out is by using trigonometry.
Okay.
And we're not going to start invoking all this trigonometry.
Yeah.
I don't want to go into that. I also don't have the best grip on it, and let that be a lesson to you. You don't need to be some, oh, I'm a maths whiz. I understand all the Pythagoras theorems. I've got them all memorized. You don't need it. All you need to know is this gives you an angle of rotation from an X and Y position, and then you can start using it. So now Scrubs is in the chat there. He uses 8 and 2 all the time. Yeah, definitely. I know that. Yeah, Scrubs is a big proponent of these math functions. Super helpful. Even if you do understand all of the math yourself, super helpful to just reach for one of these tools when you need it. So what we want to do is to only do this if we're pushing the stick, and we can ask if we're pushing the stick very easily. Rather than having some combined if statement like this, if c.lx is greater than 0, or if it's greater than 0 point something, and c.lx, or c.lx is less than minus 0.1, right? Because we have to check if it's going either left or right. We could combine these two with a function like abs for absolute. So we could say if the absolute value of the left stick is greater than something, like 0.1. Well, now we know that this left stick is being pushed in either direction. And we could check the y-axis as well. Or we could just check the length of the vector that is described by our stick. So we're taking our x and y axis position of the stick. We're chucking it into a vector. And if the length of that vector is greater than 0, then the stick is being pushed in any direction by some amount.
Perfect. Yeah.
Any direction in some amount. So if we do that, we are only setting the rotation when we push the stick, and it will retain whatever the last direction was.
Yep.
So a lot of explanation, and I'm sorry if that went on a bit longer than you might anticipate there.
No.
And it's only a few lines of code, but they do need some explanation. And this, this is I've written these lines again and again and again and again myself, and that's why I remember them off the top of my head. If it feels like it's sort of, oh, how am I going to remember that? Don't worry, you're not supposed to remember that after just seeing it once. You're supposed to remember it after you've tried it and implemented it yourself a few times, and only then. So practice is what leads you to that. So with that all out of the way, we've got our player controls. We're moving just as we might want to. We could tweak the speed. Maybe we want to actually reduce the speed a little bit of our X and Y because we're moving very, very fast. Maybe we add a little modifier to our X and Y values so it's a little slower, or maybe even more. Maybe this number here becomes a variable that we then adjust with some power-ups, right? Maybe you can collect a certain type of item that changes this number and makes it higher, thus giving us a speed-up power-up or something to that effect. Maybe we change this number when we move over certain types of terrain so that some floor is very sticky, some floor is very slippery, right? Just giving you an idea of the sorts of things that we might start customizing later.
I think that also gives everyone a little bit of insight in how they could possibly use exactly what you've put here for Mousey in this case into their own game for, a wide variety of different kinds of games with different mechanics, using this as a really solid base for that player movement.
I think it's something that you can just copy and paste directly. It is very helpful. And speaking of copying and pasting, we're going to cut this. And I'm going to make a function to keep this very tidy.
Okay.
Called player controls. We don't need it to return anything to us, but now all that player control stuff is handled. It's out of the way, and we need just put it here, like so, and our main loop remains nice and clean.
Perfect.
So it still works the same program. It's all fine. We've just put it out of the way into its own little function. Super, super helpful to do this as you go so that the program remains nice and easy to manage. This is definitely one of those habits that you can pick up where if you do this early on and you start this way, it will lead to less stress in the long run using functions. Even if that function isn't so, in our last stream, I remember talking about, that the time to write a function is like when you're writing the same thing again and again, if you remember.
Yep.
And it was like, oh, this function's really obviously great because it's saving us so many lines of code. It was like our printing function in the quiz.
Yes. Yeah.
And it's like every time we use it, we're saving like 6 or 7 lines, and that's super brilliant. But even if it's a function that you only need to use once, like player controls, like we're not going to use this again. This is just our controls, but it just keeps it out of the way. It's just somewhere else, and we don't have to worry about it. And if we need to correct something in the player controls, we know exactly where to go. We don't have to, when this main loop is really, really big and unwieldy, we don't have to go around the code looking for it. We can just go to exactly where we want. I might also just create a bookmark here and add a bookmark for player controls. And now when we click in the right stick, we can access this from anywhere in the program super quick.
So cool. So that's the first time we've done that on stream. But that's just a fast way of jumping into a certain section of the code. And I think, like everything that you've been discussing so far, we've got a very simple bit of code here currently, or a simple program, I guess I should say. Yeah. But as this gets bigger, having quick access to those things, if you do need to make any changes, is just saving your future self a lot of hassle.
Indeed. Super, super helpful. I would recommend, keep your bookmarks being made as you go, because it's easier to do it as you go than it is to like write through 2,000 lines and then say, right, time to organize my program into bookmarks. You might want to then chop and change it later, but it's just good to sort of keep this up as you go. Saves doing too much later. Okay, so that's getting the program to the point that I really wanted to get it to before we add the map. So now I'd like to branch off and start talking about the map. But before I do, Dom, might I just take just 30 seconds?
Yeah.
To just nip out a second.
In fact, this is probably a good time for us to do a quick drink break anyway. I'll pop a little be right back up on the screen, and those of you at home, if you want to take a moment to grab yourself a drink, stretch your legs, then this will be a good time to do it. You won't miss anything, and be back in just a couple of minutes.
Awesome. Thanks, Tom.
All right. Yeah, I'm back. Got myself some water. We'll give Dave a time to come back as well.
Just got back then.
Hey, perfect time.
That's good timing.
Let me bring down the screen as well. So your code.
Excellent. Okay. So let's have a quick look at the chart before we move on. See if I missed anything.
I saw Scrubs a couple of minutes ago saying position/velocity/resistance is Or to all of my physics sim.
Oh yeah, oh, that's brilliant. Yeah, so that's one of those things that really ends up blowing your mind, and not to sort of reduce the complexity of it, because something that's is a bit of a pet peeve of mine really is things that once you understand something, it's very easy to sort of think, oh, that's actually really simple, and the reality is it usually is a lot more simple than you might think. But to people who don't understand it, it's anything but.
Yeah.
And so you have to still remember that that is how it is to other people. And just because you're calling it simple doesn't necessarily, like, it doesn't really help others come to terms with it, because it makes them think, it might make them think, oh, well, if it's really simple, why don't I understand that then? And the reason is because it is actually quite complicated and intimidating, because these terms are not super intuitive. And a lot of us haven't done any math stuff since we were in school. And or we just haven't been exposed to it yet. But I guarantee that when you do understand them, suddenly you are mind blown by how simple it is.
Yes, that eureka moment.
Yeah, and the bit that blows me away is that we talk about any of these different physics things, it all just boils down to addition and subtraction. Whether it's, even if it's multiplication, that's just addition, and if it's division, that's just subtraction. If we're talking about machine learning algorithms, like modern machine learning algorithms that operate, in these neural networks, it's actually just really doing something called a dot product on like layers and layers and layers and layers of data, and that's just repeated additions in a particular order. And it all just comes down to adding stuff together, which just blows me away. Like all these amazing things, all this incredible functionality and maths and wizardry. And if you wanted to, you could write it down as an incredibly long series of additions and subtractions, which you wouldn't really want to do. But yeah, it's just something that never fails to amaze me. Okay. Damn it, just dropped half a digestive into my milk. I feel you there.
Oh,
Had to make a
no.
channel. I've been there far too many times. Although if it was a chocolate digestive, at least now you've got some slightly chocolatey milk, which is, I suppose, better than just biscuit pieces.
Look at that, Dave. Always the glass half full, but in this case, it is half full of soggy biscuit milk.
God, that's brilliant. Yes, I am. Apparently, I'm a biscuit optimist, I suppose. Yeah. See, now I'm just thinking about these really good biscuits that I ate recently, and I'm trying to move on from that thought, but I can't. These amazing, the ones that are like have quite a lot of chocolate on them, but there's still a decent amount of biscuit, but like the chocolate sort of goes past the edges. And
yeah.
You can like still see the biscuit on the back, but it's got loads of thick chocolate on top. If you take two of those and put them chocolate side together, okay, and then dip that into tea, then it creates this like central layer of melted chocolate, which then, collapses brilliantly with the biscuit, and it is just
that sounds
exquisite.
Amazing.
So yeah,
biscuit,
the
high cuisine
technology. Yeah. Okay. Right, moving on. Hard to move on from that, right? So we're going to now look at. I'd like to show off a bit of the map editor, Steve Club Biscuits. I've got to just say, what a great shout out there. You take an orange club, okay? Take an orange club biscuit. If you've never done this, I implore you, take an orange club biscuit and bite off a little bit of either side, okay? And then use that biscuit as a straw to drink some hot tea, okay? And then that will melt the biscuit in the middle. And then before it collapses, you eat that, and it is just unbelievable.
Wow.
Now you can do that with a whole variety of confectionery, and I urge you to experiment. It's once you've discovered that, there really is no going back. But it can be a bit messy, so don't do it in a dinner party or anything, unless everyone else is doing it.
That could be the whole theme of the party.
I mean, please invite me to that. Like,
this is the biscuit strategy party. It's gonna be, that's where all the coolest kids are.
This is my kind of party, honestly.
Yeah.
God. Okay. Right. I'm going to go back to the main menu here, and we're going to open up the map editor.
Mhm.
So it can be a bit of an intimidating place if you don't know what you're doing, and there's a few little techniques that are quite helpful. So I'm going to go into our tools here, and we'll go map editor, just like we did with the image editor. And in our Mousey test program, we're going to make a new map, and we'll just call it test map.
So this is a very similar process to what I did when I made Sprite.
Very much, pretty much exactly the same. In terms of how it, obviously the only difference is this is a map and not an image, but everything else is very, very much the same. It's a file that exists within your project file that you access. So we press plus, and now we're going to choose assets to use in our map. So it's going to now take us to the media library, and we can go through any of the Fuse media and select some different assets to use and add to our map library, and then we use those assets to draw the map. Okay.
Gotcha.
Now there's a lot of assets in Fuse. There's a lot, and we could be here all day. In fact, you could even create your own tiles using the tiled image feature in the image editor, like we saw earlier, and then you could load that image into your map and use those to create your own map. So you very much can use your own textures and still have access to all the functionality of the map editor and the sort of extra features and the advanced stuff, the collision and whatnot that you get access to there.
I'm sure that would have been a question in chat in a few seconds. So I'm glad that you've answered that one, because I think knowing that the huge library of assets exists is so wonderful, and I think for so many people who are more interested in the code side, they'll be so glad that they're not having to go in and painstakingly make every single sprite for their maps, but also knowing that if you do get to that point where you're wanting to create your own, there is the function there in the sprite editor that we used before to make those tiled, they call tiled assets, is that what they're referred to as?
Yeah, you can call them a tile sheet is a very sort of standard way, or a sprite sheet.
Those sprite sheets can then go into the map editor.
Yeah, I would call that a tile sheet personally.
Okay.
I mean, in Fuse, it's called a tiled image because it's still an image, but we tend to refer to them as tile sheets. Pardon me. Okay. But so we could go through a bunch of these different things and find some assets that we'd like to use. We did have a brief chat about this before the stream, and I think it'd be really good to use these assets from Untied Games. Some brilliant assets in here, especially for these sort of simple maze sorts of games. And we're going to go into this little folder called Maze Puzzle.
Perfect.
And we've got a bunch of different things here to look at. As you can see, we've got some characters. You could take a look at one of these, for instance, right? We could look at a little animation here and have a look at what it's looking like.
Slimy guy.
Little slime dude. But what we want is one of these tile sets here, these tile sheets. So there's a bunch of these different ones. We've got A, B, C, and D. And obviously, and maybe an E. Yes, as well, an E. But now we don't really want to view these as an animation because it's not really used. It's not intended to be used that way. These are to build something with, and I think we were discussing that we quite liked this one.
Yeah.
And I think as a placeholder for now, this will be very, very, very usable for us.
Definitely.
I think, I'm just wondering actually. Yeah, we'll go with this. Now, my map creation skills, I'm going to just do a sort of a pre-excuse here. They're not the best. Okay? I'm not a pixel artist, so I'm not going to have the best inclination as to. We might make some mistakes, but we can always fix them. So once you've decided on the tile set that you'd like to use, and it doesn't have to be one, right? In this window, we can add a bunch of stuff to our map library. So let's add this to the map library with the Y button.
Okay.
You can see now that update's removed from map library now. If we want to, we could go and select something else. So if we wanted to place some of these mixed objects, right, we could add one of these to our map library as well. You could add a whole bunch of stuff. But once you've made everything, once you've added everything that you want to your map library, and since we're just making a simple map, we're just going to stick with this for now.
Yep.
You press the plus button and it will travel to the map editor. And it's very, very similar to the image editor. And as you can see at the bottom there, we've got our sprite sheet. If we press A, we're now opening that sprite sheet and we're looking at all the different sprites here.
Perfect.
Okay. If we press the L and R buttons, we exit this. And we could then press L and R again to go back into the media and to choose more assets. So you don't have to, it's not like a hard committed thing. You can always go to and from. Okay, so that's how we do that.
Now, I can imagine you get a level in and you realize, oh, actually, I saw something else there in the asset library that would have been perfect to add to this. So you could go back in and add more as you go along.
Very much so. Yeah, exactly. You don't know necessarily what you're going to need in the long run. So, you know, it's quite helpful. So this intersecting blue pair of lines here, this point in the middle represents game world coordinates 0, 0.
Right.
So when we positioned Mousey on the screen, it has a default position of 0 on the X, 0 on the Y.
Yep.
And so that is this point right here.
Gotcha.
Right. So if we just load in our map and just draw it by default, anything we put here is going to be where Mousey is. Right. Now later on we can do all sorts of clever things, like we can create little flags in our map as our spawn locations and then use some code to spawn them in a particular location. But the reason I'm talking about this is I like to make everything central around this point because it just helps me think this way. It's not necessarily how everyone works, but what we're going to do is, first of all, is we're going to change our grid size to be nice and what's the word I'm looking for? Just very granular.
Yeah.
Right? Lots of subdivisions. So we have a lot of control. And when we open our sprite sheet, we can see that our sprite, our tile, it's about roughly the size of one of these grid divisions. So I like to choose a grid division that lines up with the size of the tiles that we're putting down. That's one thing that you can do straight away to help.
Yep.
Now, another thing is you can see I can sort of freely slide around here, and we need to start placing tiles now, but in a way that's going to be nice and perfectly aligned. And we don't want this sort of free placed movement. That might be what you want, depending on what sort of map you want to make, but I like to start with a different snap mode. Now you see in the top left, you've got the snap button. You press Y and it will snap to a grid. Now you can see that we are snapped to this middle point of these intersections. Actually, I'm going to go by one more intersection here. So now we can put this exactly locked into our grid squares. And we can make this sort of, we can really make this look however we want. And I think what I'll do is we'll just sort of build them around this point. Now I'm going to just go around here and press A and start placing tiles. And this will get quite tedious if we want a massive map. So what I'll do first of all is we've placed 4. I'm going to hold down the ZR button and select these 4.
Okay.
And now we've got a new object here. And if we press the X button, it's going to duplicate that. And we can move this around and paste this instead. And if we press the X button again, it will duplicate that again and again and again. And this is just a much faster way of creating a map than, placing each tile down separately. And if I cancel this, we can also then select this entire thing and do the same thing. And we could make a massive map.
Yep.
Like so.
You're sort of stamping those ones you've already placed down.
That's right. Yeah, I'm just getting all that placed like so. This might actually be bigger than what we need, but let's just get that there done. Right. So now we've got a pretty big floor, perfectly aligned, all very nicely spaced out in our grid. If at any point, so you might have noticed then, right, you can see it if I just put this little preview here over a blank place. If I hold down ZL, we can actually do all sorts of stuff here, like scale it.
Right.
You can rotate it. And if you do this and you start placing this now, well, obviously it's going to look a bit strange. And so if this happens, worry not, right? You can just click in the left stick and it will reset that media transformation here. So we can go and we can really make the map look as bizarre as we want it to. But for the purposes of this, we're just going to stick to something really nice and simple.
Yep. So we're kind of working in a very tile-based or grid-based manner, but I could imagine with those kind of rotation and scale controls, you could have something that looks very organic or very kind of that breaks totally those rules. Yeah, that's really great.
Very, very much so. Very, very much so. Yeah, that's a good way of putting it. Yeah, exactly that. If we want to look at the full sprite sheet here, the full tile sheet, we can just press the X button and it's going to take us over to here, and we can just jump to a given tile.
Oh, nice.
Right. Which is quite a handy little feature. And what we'll do is we're going to...
Could I ask, is 22 the maximum per sheet? Is that the...
Not at all.
Oh, right, okay.
In fact, nowhere near. This is a very nicely laid out tile sheet with everything really nice and sort of... it's all in one little category. This is these tiles. So there's 22 of them in this particular one. This is all up to the artist, right? This is the artist's decision of how to lay these out, and we've just taken that data and put it in there as they want it represented. But some of the sprite sheets in FUZE have got like 300 tiles in them. And they are much bigger, and of course, some of them have got animated series of tiles. You can actually create animation ranges in here and put those animated tiles in your map as well.
The map editor can handle animations as well. So
yes, on individual tiles. So if you wanted to do, for example, like water tiles in a nice RPG sort of screen, and obviously they're the only things you want to, or like, grass swaying in the wind sort of thing, you can create little animation regions, little animation sequences in your tile sheet that you've drawn yourself, and then use the animation map features to get those in there. One question: how will we make the game DDD? Do we have to write? Oh, so 3D. Do we have to write directly to a 3D rendering system? It's a good question, Curbs Workshop. We're going to avoid 3D for this. For the purposes of this demonstration, we're going to stick to 2D because we get to use the sprite system, which is very helpful for 2D game creation, and it translates over quite well. But FUZE does have a 3D engine and a whole suite of 3D functions and placing 3D objects that you can use as well to do a very similar thing. I just wanted to demonstrate the 2D functions a little bit more, and because the map editor is our 2D map sort of creation tool. We don't have a 3D map editor in FUZE at the moment. It is something that we'd really love to have, though. Okay, so now we need to start placing walls in our little maze area, and these tiles are all ever so slightly different, and they're all designed to be placed at different, slightly different places. But I really hope I don't make a mess of this, but I think this one of these, it's got a nice sort of, you see how they've got like this dark corner, right? Or this dark left and right corner, right?
Yep.
So I think what we want for the top left is one that's got a left side that is dark, but then it doesn't have this brighter side on the right hand side is going to be the edge tile on the other side. So I believe what we want is how are we going to do this?
So I suppose is 12 the one called 12? That's going to be the lower left corner tile. Do you think?
Yeah, it looks like it, doesn't it? Right, let's jump to that tile and let's place it on our sheet here. Now we could just put it over like so. We could place it on top. It's probably worth mentioning at this point that you can also change the layer, so you can place different layers onto your map, and so you can have objects appearing on top of other objects, sort of thing, which is very, very helpful, especially when you want sprites to appear underneath certain things. Like, let's say you've got a tree and you want your sprites to go behind that tree. You could draw that tree on a higher layer and then draw that layer on top of your sprites, which is it's quite a handy feature.
Cool.
That's what enables some more sort of complex looking sort of things. So just in the interest of simplicity, you know what, I think what we're going to do is, just in the interest of simplicity, maybe we'll just use all the same.
In which
Or maybe
case,
we
I think
can do it very, very quickly, actually, because this one is definitely going to be our lower boundary here.
actually, Dave,
Yeah, that's fine.
just before you do that, I think there was one that was like filled on all sides, and I think in the with it being a test room, it's okay being pretty visually
Yeah, it is, isn't it?
simple. I think I couldn't
Yeah, I
remember
think
which
it's a good
number it
idea.
was, but if you pull up the full
Now, I've just made a
sheet.
mistake here that I want to use as a chance to show another feature, which is just the undo history.
Oh yeah.
So if I've just deleted 4 tiles here by accident, and if we hold down ZL, we can press B, and we can go to our history here, and we can look at the last place where we wanted it to be.
Wow,
and now we're back to this point.
There's a serious number of undos there as well. That wasn't just kind of one step back. That was going back quite
helpful.
Yeah.
Was it this one that you're looking
at?
That
looks like it. Yeah.
One.
Yeah. In fact, Bori in chat just pointed out it was 8. Yes, perfect.
Excellent. So we're going to take 4 of these. I'm going to duplicate that. Oh, and it's duplicated the one underneath. So that's a nice bug there that I've just showcased on the screen. I just love it. I just love that. Isn't that great? Okay, what I'll do is I'm going to go like this. I'm going to draw them underneath, and I'm going to duplicate them from here, and then we'll just get rid of the ones that we don't want, which is something that's a bit easier to do. Oops. How many have we got left? We've got 1, 2, 3, 4, 5, 6. So I'll take these 3, put them there, put these there.
Perfect.
Get rid of these ones. Okay, and now we'll go up. So how big was the thing that we drew, actually? It was 1, 2, 3. Come on. Why aren't you being placed here? I think my Joy-Cons are not recognizing the inputs at times. Tell you what I'm going to do. I'm just going to go up and just do this manually like this, because it's just going to be a bit more expedient. I think we can just go ahead and hopefully we can just take this. No, it's taking the one underneath. That really is a really interesting bug. What an interesting bug. That's so strange. That is so strange. Tell you what we're going to do, mate. We are going to use this to our advantage. We're going to go back to a previous point here in our history. All the way back. We're going to go all the way back to here. I'm going to take this object here, draw it over that one. Right, now we're going to go back up to our tile, which was there, and I'm going to draw it underneath.
Makes sense.
To make this a fair bit easier.
Because then once we have that...
Put it there. What we should have done is put that on a different layer. I think it's just getting a little bit confused with something there. And then I can take this whole one. Yeah. Of course, that's a nice bug that we. So there you go. It's not perfect, is it? Nothing is. Nothing is. Let's not pretend that life is simple. Okay. Right. We are well on the way now. So take this. Put it there. I'll take that. Put one there. Do that. Select all this. Put it over here.
Look at that.
Right. Okay.
Got ourselves a test room.
Got ourselves a nice little test room. And what I'm going to do, I think, just for the sake of things looking a bit nicer, so I'm just going to put a darker tile on this bit here, because it's where our wall is. And I think this is what's sort of intended there by the artist, is to have a slightly darker tile where the wall is above. It's not necessary, but just to put it in there.
Looks lovely, yeah.
Okay, so we've got a map. Now, of course, we could go to more detail on this. We could get all sorts of bits and bobs. In fact, let's just try that. Let's just put like just a line here, so that we can just test this bit as well.
Yes,
sort of thing, like a very, very basic sort of mazy. Right. Obviously, if this works, then we can assume that pretty much everything is going to work in our maze. And now we need to get on to the next part of this map creation, which is the collision data.
Okay.
So if you change the mode here, we're going to go to collision. And on this, we can use these different shape creation tools to make different regions of collidable areas. Okay. And using the controls here, we can create these different little regions. I'm just selecting a region, pressing A, and then you've got various controls to like control that shape, extend it along or flip the shape, do whatever you need to do to it. I always forget which side it's going to be drawn on. There we go. So that's no problem at all in overlapping collision boxes. In fact, I do recommend that you do that because it sort of adds even more insurance. If we have an edge here, then if we really start to use some very, insane values in our movement, then we might get some strange behavior here, which is a feature of all game systems, even advanced AAA games. Have you ever gone out of bounds in a map?
Yeah.
That's why, you've got these collision areas that are just not quite aligned right, and given the right tiles, given the right speed values, we can start to make really strange things happen. So those hit boxes or hurt boxes, I would describe them as neither, but I can tell that you're a fighting game player with that lingo, which definitely someone after my own heart there. Okay, now these boxes I've drawn here have got some default sort of behavior attached to them. These don't have a name, right? These are just unnamed collision areas.
Okay.
And these will behave in a certain way when we use the collision functions in FUZE. If you wanted something a bit more sophisticated, like let's say you had some spikes in your program, and we wanted to, in fact, actually, I think I'm quite tempted to do that. Let's just do that because in this test room, we can also have another thing in there that we might use later.
Yeah.
I'm just going to go into our media because I know that we had some nice spikes in this mixed objects part here. And we've got some spikes over here, maybe some rocks. This little spiky thing here. We'll add this to the map library. Go into the map editor. Again, we're going to go over to our sprite sheet and we'll just put a couple of spikes down somewhere on the map. Okay. Now, in our collision mode, we can draw a little region over this. Oops, I've got a triangle being selected. I want a box. We want to adjust the thickness. There we go, like so. And on this one, we want to mark the area with our X button, and we can name this now. And in the code, we can read this name and then create different behavior based on the different names. And so we might have a bunch of these different spikes areas. We can ask what the player is colliding with, and we can check if that if that collided area is a spike, and if it is, we might want to make something happen in our code. And this might all come at a later point in our streams. Obviously, we're just really looking to get some movement, some collision going on in this area, in our little test area. Maybe get some camera movement as well.
Ooh.
So we've got some spikes there.
That's a little surprise for later. Maybe the spikes. You're priming some hazards for Mousey in future.
Yes, exactly. While I'm here as well, and we'll probably come back to this in a later stream as well, but I'm going to also create a location just to show off another feature of FUZE here in the map editor. Just like we could mark the boxes, we can actually just mark individual locations with a flag. And we could call this player spawn. Right? In fact, what I'm going to do is actually just put an underscore here. I like to keep everything, so we just use characters to make sure we don't have to worry about spaces. So player spawn, and now this point that's the bottom of this flag right here, this point here, this is now marked, and we can go and read this data and ask FUZE for all of our locations, and we could say, right, get the player spawn location and spawn our player at this location, which is quite helpful if we've got different levels. We can put them in other places. We could even use this system to spawn enemies or anything we wanted. We could go and, I've actually written some systems where you, using these flags, you could have something like this. You could have like enemy and then the enemy type, like bat, and then maybe something else like, well, actually, you probably wouldn't need anything more than that, but you could have maybe like items in here. You could say like item potion or something like this. And then in your code, you read all this data and you say, if it's an item, then check the next word. And if it's a potion, then we're going to put this sort of sprite in this location and spawn this here.
Right. Nice. That's a really cool system. Yeah, the flags are really interesting to think about. What could possibly be done with them. And Dave, am I right in thinking to create a flag, you simply selected a point rather than drawing a box?
That's right. Yeah, I just put my cursor wherever I want it. This little grey circle that's being drawn here. It has to be in the collision mode. And instead
Yep.
of pressing A to start drawing a shape, we just press the X button to mark a location.
Gotcha. Okay. Cool.
And it will also retain whatever the last thing you put is, just in case like we've got a ton of these different things we want to put, like enemy, 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 and it's going to remember that. It will also do that with the spikes as well. Like let's say we had 50 different spike regions in a map. We can go into the next one and say, right, spikes, 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 and it will mark them very quickly rather than typing it again and again and again.
Very handy. I've just noticed a question from Bori in chat. I'm going to read this. It seems like it would be tied to what we've just been discussing. So Bori mentions that it's interesting that you can name the collision boxes. Is there also a tile collision? I mean, is tile 1 is collision, 0 is transparent? I guess the question, if I'm interpreting it correctly, is could you basically determine that the player character is on a certain set of tiles using that system?
Good question. You wouldn't be able to go and ask for the map. That's a very good question, actually, and it would be an interesting feature. It's got some good implications that has. There is a problem I can immediately think of it though. That I can think of with that. So you're talking about getting the tile number, like the tile index of the tile sheet, that was used to draw that tile that we're currently on in the map. So like, for example, if we go back to this mode here, right, let's say we're standing over this tile, this one here, and we want to get this tile number, so whatever number this is in our sprite sheet, so this one, which would be a 0, or maybe like we're standing on something else and it would be like a 2 or a 3.
Yeah.
And then we want to get that number. Well, that I can see running into problems if you mix tile sheets in your map. Like, let's say you've got 4 different tile sheets. And of course, some of those tiles are going to have a 0, which is one type of thing. And then some of them are going to have a different. So their 0 tile is going to be a different one. I mean, for example, actually, case in point, in this tile sheet, 0 is this sort of floor tile. But in our other sheet here, 0 is the rock.
Right.
And so if we were going to get that data, then that 0 on its own doesn't really give us... If our tile sheet's just one tile sheet, then that kind of does tell us everything we need. But it would have to give us back a bit more information than just that. So, but it is an interesting idea. But using the collision boxes, you can do a bit more than it might seem obvious with, because you could layer them together, right? We don't have to just have one. This could be spikes, and it could be something else. And you can have 4 different types of thing layered here, right? You don't necessarily just need to have one thing. So it's like I just deleted the wrong one. But I could, like, let's say that it was spikes and they had some other property, like maybe...
Poison?
Off the top of my head here, but that they also, like, electrify you or something like that.
Yeah.
Right? And there are other things in the game that electrify you, but they're not spikes. Then you could have like 2 labels layered on top of each other, spikes and electric, and then you check those areas and do the appropriate things. So I hope that answers your question, Barry. It's a really good question. Right, so this is our map done.
Perfect.
Okay? We've got all the information we need. We're going to come out of this. We're going to press the minus button, and now that map exists in our program. Let's just double check. We'll go into map editor. We'll have a look at our Mousey test. There it is, test map, and you can get a preview of our map here.
Nice. I think being able to preview the code, being able to preview the sprites and the map is really excellent. It's so great to be able to see a little representation of them there.
Well, what I really like it for actually is you don't need to open it. Like if I think, oh, hang on, what was that project where I did that cool thing with the controls? I used ATAN 2, and we can go, oh, here it is. Look, oh, that's how you do it. Rotation equals ATAN. You can just quickly check.
So handy.
And you can go through and just check all the different things that you've written in your program just to make sure that it is the one that you are. That you want. Okay, so going back into our Mousey test, we'll write some code to get this map used in our program. And I know that we have about 45 minutes left. Let's hopefully we can get plenty done in that time, and we won't run over, and we can sort of wrap up in a nice, timely manner.
Okie doke.
Like that. Andy G85, that's a great feature I wasn't aware of. And Andy has made some incredible maps in FUZE. But actually, the code preview you're talking about. Right, you never noticed it. Never noticed it. I'm amazed, Andy. I'm absolutely amazed because I know that you have made some incredible things in Fuse. So that amazes me somewhat. Picked up Fuse yesterday and I've been messing around with it, trying to recreate an RPG. Any tips on making a battle system, Dave? Ooh, that's a good question. A battle system. You're going to need. If you. I'm going to try and position this not knowing what sort of level you're at, but so just assuming that you don't know much yet, I think you should become very comfortable with the concept of structures, so structs. Because to make an RPG battle system, the best way to represent the data for something like an attack is going to be to use structures that have got properties like the dot name, dot damage, dot accuracy, dot element, that sort of thing. And you can store all of that data into a nice big huge table called like moves or attacks. And then you can just select from those and then have your characters have a moves property, and you just take the moves from the big moves data and put them in there. You're going to need lots of structs, and you're going to need to get used to having these deep layered references to structs. So like my character dot move dot damage, right? So like the enemy, when it takes a hit, is going to have its HP. So enemy dot HP minus equals, character that you're currently selecting dot moves, and then whatever move you're selecting dot damage. Hopefully that can give you an idea of sort of where to look. You can have lots of these nested sort of different structure properties, and an RPG battle system is something I really want to make a project around, actually. So do keep an eye out on the videos that we might make on the channel, or on any of the worksheets that we bring out on the arena. We're about to upload actually a lot more worksheet content because I have been working very hard over the last many weeks on making more and more project worksheets for a school context and sort of self-guided learning. I said lurking because Moxie just appeared in the chat saying I might lurk for a while. Said lurking. Yes, I've been making lots of worksheets, and so we'll be uploading all of those fairly soon, and there's quite a few to come. So but a battle system would be a very good idea to cover for one of those. I know how much the kids at the workshops want to make some sort of Pokemon card system, some sort of card battle game, and I love that sort of stuff as well. So very cool idea.
I'll just jump in to say Kerr has made some incredible RPGs in GBG, and Kerr, I think based on what Dave has suggested that you get familiar with, I think we did cover structs in our third stream. Does that sound right?
This is the third, so it was our second stream.
Our second one. Yeah.
I know it feels like we've known each other for years now at this point. But we only went into some very surface level detail.
Yes.
Just to really sort of give you the sense, it's like structs can be as nested as you want. So you could have an entire struct be the property of an entire struct within the property of an entire struct within the not infinitum, but some reasonable limit. And so you can actually organize your data as deep as you want, and then that will make it a lot easier later when you're trying to access all that information. But you're going to need some sort of turn-based system. It's going to go quite in depth, but maybe we can do a video on that at some point. Anyway. Okay, hope that answers your question there. So where are we? Yes, maps. We're going to load our map into our game and then just draw it. So really, really simple. We're just going to need 2 lines to do this. Hey, Lucas in the chat, good to see you there. Nice to stop by. So we're going to just load map. So this line here, load map. Just needs a file name. And our file name was called test map, if I do believe. So test map. And once this is done, we have that map in memory. Now, Fuse can only have 1 map loaded at a given time. And so if we had lots of maps, then maybe we would have some sort of array called like maps. And we could have a bunch of things in here, test map, right? For our first level, we could have like level 1 or whatever, right? We could have all sorts of things here, secret level, whatever we end up calling them. We can have all of these names in an array, and then we would have some variable to say which map we're on, and then we would use that in our load map instead. And we'd, at some point in the code, we'd say, right, okay, now unload this map, load a new map, and manage it that way. But just for now, just for getting a test level going, we only need this. Just load this one image.
Perfect.
And then simply we go into our drawing. And of course, we want to draw this before we draw the sprites, given that we want the sprites to actually appear over the top of the map. And we write draw map. Now, we could tell it to draw in a particular place, but it's best if we just leave this on its own. Let it draw wherever it, in its default position, and make the map such that we're sort of predicting where everything's going to be. It's all in a sensible location, because the collision data and the map draw are separate. And so if we say draw the map over here, the collision data will not move with it. They are separate. It allows you to do all sorts of fancy sort of tricks with the drawing without really worrying about interacting too much with how the game works. So you could make some cool effects happen in your map, whilst not not worrying about how it's going to affect the rest of your sprites. But draw map on its own, we'll just put Mousey in the mix.
Hey, look at that.
And we have got something that looks like a game going on here, which is pretty cool.
Right.
Now, you see how Mousey is really quite big compared to the tiles? I'm just wondering if we might want to shift that around. It doesn't actually look too bad. I think it's pretty good.
Seems pretty cool.
I mean, we could actually. What I'm going to do is I'm going to halve the size of Mousey.
Okay.
And then I'm going to zoom in more so that the map fills up more of the screen.
Right.
So that we can then do some moving camera.
Yes.
And it's actually really, really nice and easy to do that if we just want it in a basic way, which is what we're definitely interested in right now. So what I'll do is we're going to set the sprite scale, and we're taking our player sprite, and we're going to give it an X and a Y scale, and then we're going to just work on these numbers. Now, we could put, the numbers in here, right? 3 times bigger on X and Y. 1, 1 is just going to be its normal scale. But if you just want to be lazy like me, and you don't want to have to write a number twice, you can just take that 1, 1 and multiply it by something else.
Right.
If I say 5, it's 5 times bigger. It's like I wrote 5, 5. If I write 0.5, it's half the size.
Gotcha.
Right.
Perfect.
And that is going to make our Mousey a little bit smaller. And then to compensate for all this, we're going to zoom in by a bit more.
Right,
So
which was... Oops, sorry, I was just going to say that was our set sprite camera, which was 0, was it 1 previously?
It was 3 before. I'm going to put this here as just do X, Y, Z in a comment just above, right? So we've got our zoom. Now Z is not for zoom, it's for the Z axis position, but it just so happens to line up with the word zoom.
Perfect.
Really, really neatly.
Yep.
So we're going to go in by a fair bit so we can, maybe even more actually. Yeah, that's quite nice. And we've got. Okay.
So we currently can't see the whole stage, and that's what attaching a camera will, or having some kind of control over the camera will allow.
Yes, indeed.
David, I just applaud you for matching those tile edges so nicely with the camera scale, or the scale of the world here. Look at that.
You can, and I can pretend that I had any ability to predict that. But sure.
By the way, I need to bring attention to as well to Arch's comment saying, starting off making a Mousey game at a sensible scale, unheard of. Now, Dave, when I made Mousey's Cheese Maze in GBG, I accidentally made everything, because it was on the first day that GBG came out, I started working on it. I made everything at a ridiculously large scale in hindsight, as we learned more about GBG. And to be fair, I think people that had a little bit more forethought than I did, would also have acknowledged that probably even on day one. But it caused us so many problems. So Arch is, I'm sure, glad that you're here working at a sensible size rather than the first time round.
The passive aggressive comment, I love it. um, yeah, it's something that I have come to learn as well through pain. It's just that's how we learn, isn't it? Like it
Exactly.
was you the more you do, the more you sort of start to be able to predict, oh, okay, I'm going to need this and this to be uniform from the
Yep.
beginning rather than. But it's sometimes there's no amount of prediction can really help because it depends on what you want to work with.
Yeah.
If we want to work with a given sprite that is of a much larger scale, and then we're going to have to sort of maybe come up with some new rules on the fly and break those rules. But generally speaking, you want to try and make everything as consistent a scale as you can, which is why I asked you to do a 32 by 32 sprite. So we're not too outside of the realms of these 16 by 16 tiles.
Hmm.
So it looks really nice and cohesive.
Wonderful.
We're moving really, really quickly because of the speed of everything and the size of everything. Just the numbers and the scales that we're working at are such that that we're moving very, very quickly. So I'm just going to slow things down somewhat.
Mhm.
We'll go into our playing controls. In fact, I'm going to use the bookmark system to do that. Oh, play controls. There we go.
Perfect.
We will go by quite a bit less.
That seems more
Bit
reasonable.
better. I think we can even get away with a bit less than that, to be honest. Yeah,
Yeah,
it's
there
nice.
we go. Look at that.
Lovely. Okay. Right. Next step. Let's do some camera movement because that seems to be what we are thinking about next. Now, to do some camera movement, right, these are the values that need to change. These values right here. And in order to change them, this is going to have to be a variable.
Yep.
And we're going to have one of these set sprite camera lines in our loop because we're going to need to constantly update it. So we'll make a camera variable. And I'm just in the sake of ordering things around nicely, I'm going to put our C equals controls there. I tend to do this way around. So this is just down to me, really. Yep. Okay. I like to have things in a particular order. I'm going to put some labels in at this point, player setup.
That familiarity of having a certain setup means going back through this stuff, I'm sure, is a lot easier and a lot more intuitive. And
yeah,
everybody
it
has
does help.
those preferences.
I mean, I also like to, I know this is part of the player setup, but I like to do all the loading first. The reason being, if we add a bunch of audio to this, and we're loading audio takes a lot longer to load than an image because it's just much more dense data, especially in the format that everything is in FUZE. And if we put it all up front here, then it just gets all of that loading out the way. We could maybe have a little loading screen to say, I'm loading some stuff, be patient, and then we never have to wait again for it to load.
Yep. But
if we had some loading at different places in our program, well, then we might suddenly get a little drop in frames or something going on. Sometimes it can be beneficial to do, but in these like simple programs, I just want to keep the template pretty strict.
Yeah.
So we load everything. We have our global variables, and we then have our like actors setting up. Then we move on to the main loop, and then we can have all of our game functions. Right. After that, and we've got something like a basic project template now. Right? It's looking a bit more sophisticated, and we have something to keep adding to as we go, with some idea of where it's going to go. Very, very helpful. So with our global variables, let's just zoom in a bit actually. With our global variables, we're going to make a cam variable, and this is just going to be our vector. So 006, this now becomes cam. We'll do that just here, just because we're going to want to set the sprite camera as just a default thing anyway. But maybe if we wanted a little intro for our game, right, we're going to want to do this a bit differently. Maybe we start zoomed out and then we zoom in. Maybe we do all sorts of stuff. But I'll just keep it here for now. So set sprite camera can be okay there. We're going to come down into the main loop. And we will, after we read the controls, it doesn't particularly have to be there. It's just I like to have the controls be the first thing that happens in the frame. Then we're going to set our sprite camera. In fact, no, actually, we'll do that after player controls. Oh, it's kind of up to all of us really, but it just depends on the sort of the order of things. So what I'm thinking is we're going to be adjusting the player position with our player controls. right? So the player position is going to update. And then I want to use that player position for our camera.
Okay.
So we could just put our player position in here. That's going to work.
Right. Which would effectively be like locking the camera to the player position through the set
In fact, let's
sprite
just do
camera.
that. Let's just do that for now, right? Put this at, what was our zoom? It was 6. So if I do that and we move around, the camera's now moving.
Yeah.
Rather fetching, really.
Mm-hmm.
However, I tend to, just out of habit, I like to separate things. So instead of having that be just the player position,
Yep.
we'll have that be cam. And then if we want to do something else to cam or something else to player, then it's not going to just, it basically keeps everything separate. So otherwise, if this is already always on player, then if we want to have a different mode for our camera, right? Like we could have a mode variable for our camera, right? We could have something like if cam mode equals I don't know, like player cam, some sort of variable here, right? Then we're doing this, right? And if it's a different sort of camera mode, then we could make it follow something else, and then we don't have to keep rewriting this line.
Is that separation just to really kind of future-proof yourself, or give you room in the future to think, oh, if we do want to separate the camera, then it's easier to do that rather than just tying that all into the player position?
Totally right.
Got it.
Totally
Okay.
right. That is, I'm really glad that you came up with that word. There, it's future-proofing, and it's something that that you'll just do better and better as you go. There's a lot of future-proofing that we haven't done here that we should have, well, quote unquote, should have done, right? We're kind of totally fine because we can, this is justifiably just, it's an intro level sort of game project.
Yep.
But of course, if we really wanted to future-proof ourselves in like loads of different ways, then we would have already made our map arrays and with all the different stuff. We would have made a ton of different things. This player setup, this might be in its own function sort of thing. Maybe this will be something that we do a bit more sophisticated, but we'll come to that later.
Yeah. Put it another way, you're showing these processes off to me and maybe some people in chat who have not played around with these before, but there'll also be people in chat who are experts and they can think of a million ways that we could have done these in more future-proofed or kind of tricky ways to kind of get things to be a little bit more streamlined or but for my sake and maybe some people in chats, it's so great to be going in this more foundational direction.
Glad to hear you say it. That's putting it very, very nicely. So now we've got camera movement, and all we're really left to do to get this to be something of a fairly sophisticated little project is to chuck our collision in.
Yes, right. So we've defined that in the map editor, but it's not. It's not referring to that currently.
It's not being used, is it? Because we can just walk straight over where these collision boxes are, and so it's not really respecting it right now. So it's actually trivially easy to make it do that when we use the map editor, when we use collision boxes, and we use sprites. It's if we want more sophisticated behavior than just I can't go in here, then it's going to start getting into some more complex code. But if we just want very, very simple map collisions, then we will do, where will we do this actually? Well, I think we should do this. We'll do it just here for now. Okay, so we'll do it here. We're going to create a variable. We'll call it map collisions. And into this, we're going to store this variable, collide map.
Okay.
Now, in the brackets for collide map, we need to tell it a sprite that is going to be colliding with our map collision data. Okay. So that's going to be player. Now, actually, we could call this player map collisions to sort of, not pap collisions, player map collisions. It's getting a bit long. Maybe we call it player map call. It's a bit easier to sort of think about. Now, we actually don't really need to have this in a variable for the purpose purposes of just basic collision data, because this not only applies the collision behavior, but it also gives us a lot of information about those collisions that are happening. It's an array of collisions because you might be colliding with multiple map areas at once.
Oh, yeah.
And
You're in a
it's not
corner,
just
for example.
one collision. Exactly,
Or
in the
if-
corner is a great example. Or if we've layered multiple boxes on top of each
On
other.
the spikes, yeah.
Exactly, yeah, like with that sprites and electricity example. So this will return an array. Now, if we want to look at this information, we're going to have to, write a little loop that goes over this array and checks things. But on its own, that will stop us from going into walls. And now we've got collision.
Easy.
Now, it does not apply collision to the spikes.
Mm-hmm.
And that's because we have given this a separate name. Now, we could make it do so by using collide map area. Player spikes. Call. Collide map area. And then we tell it the name of the area we want to collide with. And this will now do the same thing. It's going to apply. Oops. We need the sprite as well. Yep, sorry. Player as well. So that error was just saying, I should actually not quickly go over that. It's saying we have an incorrect number of parameters, right? Collide map area needs more than just the area because we need to know the sprite that's colliding. So I'm telling it the area name and the sprite that we are colliding with that area. And now we will get this behavior.
Perfect.
But we could do anything we want here. We could put a true or a false here to say if we want it to actually even resolve that collision. So if we put false, it won't resolve it, but we still have all that information about it. So it could tell us how much on the spikes we are.
Yeah.
It could tell us, if we're colliding with it, what direction we're colliding with it from, and how we need to be pushed out of the sprites, out of the collision data to resolve that collision.
Would it be fair to say
total control?
Would it be fair to say in that instance where it's not resolving it, it's essentially sort of listening for collision rather than Okay.
Doing.
Yeah.
Exactly that.
Okay.
Exactly that. It really allows you to. I think that a really good way of thinking about this resolution bit here is imagine it's a door. Okay. Imagine we're colliding with a door, and this value is just if it's open or not.
Right.
Or actually, it should be if it's closed or not. Sorry.
Yeah.
So if closed is true, we cannot go through the door.
Gotcha.
If closed is false and it's open, then we don't need to resolve that collision and we can walk straight through the door. So you can imagine that if you had a map area like a door, this might be a variable that is whether that door is open or not, or closed or not. Sorry. So you can maybe see a bit further ahead there. That's the sort of code that you would write for something like that.
And Dave, if this is not the right time to ask this, we can come back to it perhaps. But for example, is it the map collide that you're using above rather than the area? Collide map, excuse me. That could also be player, comma, and let's say cheese as well. If you were to add things in there, is that you can add more objects that are to interact with the collide map or not?
No, that would have to be separate. So we'd have to do something like cheese map call.
Right, okay. So you do one of those for each of those things.
For each of the sprite things that you want to collide,
Gotcha, okay.
That's right.
Right, of course, because this is specifically the player map collision.
Yeah, I mean, that's just the name of the variable. I mean, it's the thing is if it was in that way where we could have up to any number of things that are colliding, then we really never know how long this function is going to be. And it gets a bit harder to say because you do also have this true or false property of if you wanted to. Right, so we could put false here, and we can say listen for the collision data, but don't do it.
Yes.
And so if you had lots of different things in there, then it kind of gets difficult to know like how this function ends up looking when Fuse is being read and interpreted. So we just keep it to one in here. So you just say collide this sprite with the map. Here's if I want it to be pushed or not. And yeah, that's that. So we have a simple project, map collision. We've got movement. We've got our own custom sprite. We've got our own custom. I think we're off to the races here.
Yeah.
To be honest.
That took me about 4 months when I did that before.
I mean, yeah, this stuff. If you don't have someone sort of helping you along, then yeah, it can obviously. It's going to take a bit longer. I don't mean to make it sound it's, oh, look how simple and easy it is.
No, but
when you break it down and you take it one step at a time, actually, some of this stuff is it is easier than you might think, because it feels intimidating, and you get your head around it, and it's like, oh no, I get that, I can use that.
I think I think I mentioned it before when you were handling the player movement, but the things that we've covered here, we're using Mousey's Cheese Maze because it's something that people will be familiar with, and they'll know the mechanics of. But you can immediately think of a million different kind of genres of game that would utilize the same kind of things here, the collision. And as you kind of expanded upon the way that you can check whether doors are opened, and I suppose link those into other conditions as well. Yeah, really
absolutely.
amazing.
And I'm just going to shout out Voxy in the chat, because they've mentioned a game that I really love. They said this is like Babbitt is You,
yes,
but with longer words. And that's exactly right. In Babbitt is You, that variable, whether it's being pushed and resolved, this is the entire premise of the game. Whether it's, which properties are assigned to what. Can you push the rock, or can you just walk straight through the rock, or is the rock now this other collision type, which is actually something that hurts you, and all sorts. It's a fantastic game. If you haven't played that, people in the chat, do look up Babbitt is You. It's a fantastic game, brilliant brain teaser game. Yeah. Okay.
I'll just also read RGC Exists comment saying, during the development of the original MCM, Dom was pretty much relying on chat. He wasn't exactly on his own. That is also very true. Chat always keeping me in check.
Oh God, that's very, very useful, really.
Yes, yeah. I mean, yeah. Everybody in chat is so skilled, and yeah, it wouldn't be what it was without everybody's.
Although apparently chat did spend a lot of time making bad puns instead of helping Dom.
Hey, it's the trade-off. It's the trade-off you have to make.
Definitely. I'm certainly I'm definitely a fan of some bad puns. I'm weak to that. I'll admit. The font of knowledge I'm still reeling from, and wish I'd thought of a. I think I need more sleep to think of better. But that's what I'm going to blame. I'm just annoyed I didn't come up with something really fast and brilliant off the back of that. But yeah, I'm looking at the time now, Dom. And I'm thinking, the next step here would be to start adding some other things like the cheese, right? And you foreshadowed it a little bit by saying, so would you have to do like a separate variable for the cheese collision? And I'm thinking, okay, maybe we could get some cheese going. And I'm wondering if we have time for that, or if it might be a bit long, because I do want to delve into some more advanced usage of the sprite functions, like creating multiple sprites and handling multiple sprites, and how you create and remove things from a game sort of scenario. And there are some little functions I could go into that I think would be great to learn about, but I don't know if we might sort of go over the 9 o'clock point, and I don't want to run everyone over. So I don't know if it's the best thing for us to do. I could sort of show you, because I did have a bit of a test thing going on here. When you were telling me about the sort of game that Mouse's Cheese Maze is. And I'll tell you what I'm going to do, actually, just to make sure that this is really correct. Right, this is called player. So just make sure it's saved. Okay. I'm going to... oh no, not this way. I'm going to go into the image editor. I'm just going to copy that mouse over. So image options, copy image, copy to another project. We're going to go into Mousey's Cheese Maze test, which is where something that I was messing around with. We're going to copy that over to player, and now that image exists there as well.
So
we're going to come back.
For reference, that's the a sort of test that you were doing ahead of time when I mentioned, you know, what is involved in Mousey's Cheese Maze.
That's right.
Yeah,
right.
got it. I mean, I understand why you'd want to copy that mouse. It is some of the greatest sprite work that has ever been.
Because what I've got in this little test is just nowhere near as good. I mean, as you can see, I've got very, very similar things with our sort of X and Y speed, but I've also got something with the cheese going on. And I thought maybe you might like to see a bit of this. I know I did show you a little bit cheekily before, but I think the chat might like to see it as well.
And I guess just before you do that, I'll also say, I think...
No, I need to rename this anyway, so...
I think showcasing what you did here will be really wonderful. And I think I'd like to look at the kind of cheese in our one next time, because I would really like to dive into those things that you mentioned as well. And I don't want us to feel the time pressures on that. So I think it would be really lovely to kind of end up... I mean, first of all, what an achievement to have the player movement, also have the mouse looking the correct direction, have the custom sprite, custom map, collision, moving camera. That's incredible. I can't believe that, you know, you covered so much here today. So this will be a nice little teaser of what's potentially to come if this is the direction we go.
Brilliant. I think, you're echoing my thoughts there exactly. I'd like to hit these sort of sprite creation and sort of handling lots of different arrays of things when we're dead fresh, and we can really, you know, and the chat can really absorb that, so it's to everyone's benefit, rather than cramming it all into like the last 15 minutes or so.
Because I know you could fly through it, but the other thing that you're really amazing at doing is making sure that everybody is following along, and that takes a bit of time. So that makes sense. Yeah.
Appreciate it, Dom. That's lovely. So in this program, I am using some of these functions a little bit to initialize some cheeses. Now, the number of cheeses I'm initializing is 10.
That's a great phrase.
Tell you what, I mean, I am all about initializing cheese in my own life. Okay, especially Stilton, mate. I initialized a fair bit of Stilton earlier, actually. Yeah, it was good. It was a good session.
You know, you're using your life experiences in your programming. It makes sense.
Always calling on my life experiences. Yes. Okay, so this is going to create a bunch of cheese. Now the mouse is really quite small here, so what I'd like to do actually is just maybe change the size of a few things. So let's set Mousey to be a bit bigger. That's better.
Yeah.
And I need to add the ATAN2 thing very, very quickly. So let me just do that very, very quick. If length c.lx, c.ly is greater than 0, then we want to take our rotation and make it ATAN2 of c.lx and c.ly. And we've got right, great. So you let me know in the in our previous chat that it's a hoovering system for the cheese sort of thing. Right? So now obviously we could have some sort of cheese collision where we just go over it and just collect it.
Yep.
But what I was working on is actually how to make that hoovering sort of technique work. So I've got like a distance threshold.
Okay.
And it's checking all of the cheeses all the time to see which ones are closest to us. And if they are close enough, then when we press A, cheese is going to start moving in to where we are. It's something like that. And we actually could chase all the cheese around and make it all do this. So it's a bit strange. We're actually going to get all the cheese into one place, sort of collate all the cheese like that. And right. But something like this is sort of what I was picturing for our cheese hoovering method.
Absolutely. Yeah.
That sort of, yeah.
Yep.
Great stuff. Great stuff. And there's a few things that we can play with here as well. Like this number here is the rate of our cheese movement. So if we make this much bigger, then cheese is just going to come flying in. In fact, it's going to get a bit strange there. What I need to do is just quickly just clamp this. Cheese.t equals min cheese.t and 0. No, 1. That's what I want there. So it's going to reach this middle point like that. Clamp that cheese value like so. So something like that would be really great. And then, of course, we can just go crazy because if we make it all in a nice function, we can put lots of cheese in and just start hoovering it all up beautifully, which is really, really nice.
Yeah.
I mean, you don't have to stop there. You can have any amount of cheese. Well, not any amount, but sensible amounts.
Mousey in heaven right now.
Mousey's cheese bliss is what they say. Mousey's cheese-induced coma, maybe.
Yes. That's the last stage because Mousey just couldn't eat anymore.
Yeah. Maybe this could be like, once you beat the final boss or something, we go to we get all the cheese under there. Steve's Gaming, I'd have the cheese under the mouse sprite depth. That's a good point. Obviously, I was just worried about sort of getting the cheese to behave like this. So I really wasn't thinking too much about like the order of drawing. But yes, definitely we would want to draw our cheese underneath the mouse so we can see Mousey on top of that. Now we could do that by just manually drawing it in a certain way, or we could actually just set all of our cheese depth to have a much just to be different. So we could, in our initialization of the cheese, we could take the depth property and make this. Now I forget actually that is it 0 if that's. I forget if it needs to be the ending value or actually I think that's what I'm going to do here because now we'd have to like keep what we do we want the player's depth to be 0, I believe. I always forget like which way around it is, Steve, because I don't tend to use it. I just sort of like manually draw everything in the order I want to draw it in. If we set our player depth to 0 and then set all of this cheese depth to 1, is that what we want? Other way around. So this one is 0, this one is 1, and now
there we go.
Mouse is on top. So lower depth comes after, so higher depth is after. Brilliant. So yes, there's lots of stuff to play with there. We're going to have real fun, I think, when it comes into getting these mechanics in the game. And I very much look forward to carrying on with this project. It's very exciting.
Yeah, Dave, thank you so much for. I mean, I say this every time, and it's true every time, for being so generous with your knowledge, so wonderful at sharing that and communicating that, and I think very, very exciting that we got such a huge amount done. I mean, I was really carrying it today, I would say, with the mouse sprite. But yeah, you also did a bit too.
Love it. Yeah. So you're right. Though. I mean, it would have been a bit dry without the mouse, I think. Yeah. Yeah. Well, thank you for being such a gracious carrier and being the MVP. I really appreciate it.
No, but
I'd like you to have this project now.
Hey,
actually.
okay.
So I'm just going to take out the latest one. I've made a little thumbnail here as well by pressing the minus button in the program.
I missed that. That's really, really cool.
Share program. Oh, I've got a cat in the room now. He's scratching away at the carpet. Okay, so I think maybe it's the mouse being on screen has led him up here. So I've shared the program. If you now swap back over to yours, Dom, and then you can go into so back into share there.
Yep.
And then go into the friends part where you can see all the different friends menu. Go to Dave. And there's Mousey test right there. Select that with the A button and overwrite it.
Yep.
And now you can go on open and press plus and run the program and bam.
Nice.
There you go.
So another really showcase ability to very, very quickly share stuff. Collaborators on.
Yeah, I think that's to be honest, it's not a feature I've used too much because I tend to work pretty solo on the projects I work on. But that was so smooth and painless that I think I'm going to make more of an effort to try and do that in the future because it's a nice feature actually. If I do say so myself.
Yeah, it's fantastic. Man, that's so wonderful. Dave, of course, I was being cheeky before, but you really did such an amazing job of talking us through all of this and making it make sense and building up that knowledge that we've kind of slowly started to gather through your wonderful guidance over the last couple of streams. So really, really appreciate it. I'm sure chat does too.
I mean, I was playing along with the joke, but I actually do kind of mean it because it's been you've provided. I mean, even though the opportunity is there, right, for us to do this. I mean, obviously, could sort of go and stream this sort of a thing, but when somebody comes along like with an idea and they say like, I want to do this and this, it makes it happen. So you have really got a big part to play in making this happen. And I love the connection that we've made. I think that it's just been great. It's been positive to positive, and you're just as responsible for that. So I do thank you very, very deeply. It's really great to do this, as always. Not just being very polite. I think you're a wonderful person to work with. I really enjoy this. So I look forward to the next one, where we can get some cheese going and feed this poor old hungry, worried-looking mouse.
Yes, he is very worried looking in this.
He looks so worried from that angle.
I mean, he's right to, I suppose. You did kind of preload a spike trap in here. It's not going to cause any harm right now, but
I wouldn't want to be trapped in this room. Let's be honest. Not even any cheese in here.
I know. Dave, I can see some cool gamers for you in chat, and I think that's really, really. Thank you so much. And I'm going to post. I guess while I do this, could you also let people know where they can get FUZE4 and where they can find you? I've got a link to the FUZE Arena that I'm spamming at the moment, but could you, kind of
absolutely can, yeah. Thank you very much, Tom. Yeah, so best place to go is that YouTube link at FUZE Arena. That's going to give you access to all of our game jam streams and any tutorial content that we make. But also, I would recommend going to the FUZE Arena forum, where you can catch news of all the latest bits and bobs going on in FUZE, any sort of press stuff that we're doing, any of the latest things that we're adding to FUZE. You can report bugs, of course. It's all there, any competitions, all that stuff, but mainly also it's where the community lives, and it's where you can get incredible help from our lovely group of just fantastic community members, a few of which have been in the chat tonight. And I really just want to thank you guys in the chat for coming and watching and supporting us and being a part of it. It's really lovely to see you all, and thanks again to everybody in your chat as well. I hope you've enjoyed it, and it's a real pleasure to show you this stuff and to put FUZE in front of more people like this, and I hope it excites you and that it's not just you on your own. Like, you've got lots of help. So FUZEarena.com, and the FUZE Arena YouTube channel as well. We do have a Discord channel, and what else is it worth mentioning there? FUZE Arena, FUZE YouTube. If you do use TikTok, then feel free to follow us on there as well. We've got a few videos on there, and we'll be making more some coding shorts and some silly videos too. So I hope that that you check us out and leave us a subscribe and a like, and it would mean a great deal.
Yeah, give FUZE Arena a subscribe for sure. Those little shorts are super useful. Those little bite-sized kind of reminders of certain useful things and concepts. Yeah, I think everything is linked down in the description of this stream as well. So if there was anything that Dave mentioned there that you're wondering how you'd get to, I think it is below. I'll double check as soon as this is done, but should all be in the description. Nice. I think we should wrap up here, Dave. But thank you again, and thank you everybody. The FUZE community is so lovely, and it's always so amazing checking out those jams. I mean, everything on the FUZE Arena channel is great, but I have so much fun with your streams and seeing what everybody has been building. Really great stuff.
Oh, Dom, thank you so much for always stopping by. It is great to see you every time that you wave hello in there. It really means a lot that you come and check out the game jams, and that we've sort of organized it so that the communities can like watch both of us at different times, and the support is just amazing, dude. It's brings a tear to one's eye.
Oh,
you really, it's just so great. It's so great. I really look forward to being back with you again.
Yep.
So we'll stay in touch, and I'm sure that I'll be seeing you all again, and we can make more amazing, wonderful cheese fun.
Perfect.
Strangely.
I don't think it was. I couldn't have said it better myself. All right, let us.
I don't know about
that. Let's wrap up, everybody. Okay. I will speak to you soon. Discord back. FUZE4, Nintendo Switch again soon. For now, though, say bye-bye.
Bye bye.